read DTO as the message that we pass over, okay? So in here, I'm going to say platform read DTO, and we'll just call that plat. So we're going to bring in a few namespaces here. So control period to bring in platform service DTOs, and we need to bring in threading for this. Okay, great. So that's our interface created. So I'm just going to come on now and create the concrete class. So again, within the HTTP folder, new file, and I'm just going to call this HTTP command data client.cs. Okay, specify the namespace, platform service, sync data services, and as we've typed this in before, you can see it's remembered it, which is cool. And then it's just a public class called HTTP. And I realize I've just spelled that wrong, so let me just rename that. Command data client, yep, so HTTP command data client, and we're going to implement the I command data client. So we'll do a control period, implement interface. Fantastic. Now before we actually come on and implement this method here, what I want to do is make use of this HTTP client factory. So in order to do that, we use, once again, constructor dependency injection here. So we're going to create a constructor for our class, and into it, we're going to inject a HTTP client. And you'll see how this all ties together when we register this service in our startup class. And we're just going to call that HTTP client. So into here, we're going to get this HTTP client injected, but we do need to bring in the namespace of using system.net HTTP. Fantastic. And again, we need to create a private instance. So I'm going to call underscore HTTP client is equal to HTTP client. And in here, control period to generate a read-only field that we can use throughout the rest of our service, or service method, put it in here. Use it in here, okay? So let's just save that for the moment. And now we're going to come down and actually implement or send platform to command synchronous call. So the first thing I want to do is create a payload effectively that would contain our platform read DTO or information. So I'm going to do a var, call it HTTP content, and it'll be a new string content object. Open parenthesis, I'll just put in the semicolon. And the first thing I'm going to do is I'm going to serialize this object, this platform read DTO. So I'm going to use JSON serializer. I spelled that correct. No, I've not spelled it correct. Serializer. I think that's right. Yeah, so using system text JSON. Now you can see you get two choices here. You could use the older Newtonsoft JSON library. I'm using the Microsoft library moving forward now, okay? And we're just going to serialize the platform object so we can send it over the wire, basically. All right. And in the encoding, bring in the namespace for that, should be system text, there we go, is going to be UTF-8. And then finally, we just need to specify the media type, which is going to be application JSON. Okay, and I'm going to bring that back up onto this line here. Okay, so this string content object is something we're going to send over with our post request. Okay, and it's still complaining because we're not really returning anything as yet. And then we're going to basically make a post async request to our client. So I'm going to do var response equals await. Use our HTTP client, post async, and I'm just going to do a control B to get rid of our sidebar. You can see what's happening. And here we don't have a problem at all because we will solve it, of course, but we need to know where, and again, this is talking about kind of your pairing services to one another. We need to know where to send this post request to. Now we can just hard code the URI of our service in here. Okay, but that's not a particularly elegant solution. So what I want to do is I want to move in and put this type of stuff into config, okay? But for the moment, let's just hard code it, and we will eventually come back and put it into config so that it's not hard coded, which is never a great idea. So basically what we want to do, let's come back over to Insomnia. And when we tested our inbound connection in our local environment, this is the URI or URL that we want to send this to. So we'll just copy this in for the moment. Again, I just want to get this up and running and working, but we'll circle back and put this into config. Okay, so paste that in there, and then we need to supply the HTTP content along with this as well. And it's complaining, they wait over it. Okay, so we need to put in async up here. There we go, and that should resolve that. So basically it was complaining that we couldn't call an await method when this method signature wasn't asynchronous itself. Okay, so we're going to post to our endpoint and we're going to provide that HTTP content. Cool, and then all we want to do then is just check that we get a successful or otherwise response back. So if response is success code, then we'll do a console write line, bring in the namespace using system, write line, and we'll just say sync post to command service was okay. Otherwise, console write line, and I might just copy this message here, and we'll say it was not okay. All right, fantastic. So let's save that off. Okay, so we've still got a couple of things to do. We want to bring in configuration rather than hard-coded strings. So what we can do actually is up here in our constructor, where we're injecting in a HTTP client, we can also inject iConfiguration. Big duration, and we'll just call that configuration. Okay, we'll bring in the namespace for that. Now, iConfiguration is one of those lovely objects that gets injected everywhere, basically, or can be injected everywhere, so we don't really have to do too much setup there. The other thing to be really careful of, and I've made this mistake, is that bring in the right namespace for iConfiguration, because Automapper also has that too. So make sure it's the Microsoft extensions configuration that you bring up at the top. Okay, and then we'll set up a private field, so call it _configuration and make it equal to configuration. And then control period, generate a read-only field. There we go. And we can use this configuration now to inject this in from a config file. So I'm going to copy this and I'm going to do a control B, and we're going to come over to our configuration file. So we have our app settings development JSON configuration file, which seems like a good place in which to put our config for our endpoint from a development perspective. So what I'm going to do is I'm going to come over to here and into our app settings.development JSON. I'm going to create a new parameter in here, and I'm just going to call it command service. And the value, I'm actually just going to make it the kind of base URL for our command service, so we know where to get to it. So we'll save that off in here, and we'll come back to our command service. I'll do a control B to bring this down, and what I'm going to do is I'm going to take this out, and I'm going to make use of string interpolation to inject in that part of our URI into our endpoint here. Now you could put the whole thing, to be honest with you. You could actually put the whole thing in. I'm just putting the server URI, but you could put the whole path in if you wanted, which is entirely up to you. And I'm just going to make use of configuration. So basically, what we get injected in here, configuration, and then just reference the setting that we put in here, which was command service. So just copy that and put that in here. and make sure you get the forward slash. So basically, this thing here, all the way up to here, is basically going to be a HTTP localhost port 6000 and then the rest of the URI. Now again, you could replace the whole thing if you wanted in here with that. Entirely up to you. In fact, do you know what? Let's do that, because it doesn't really make sense, does it, to just have that little bit. So let's just put that in here like that. That makes more sense, doesn't it? Yeah. Okay, so basically we're just going to put the whole thing in. All right, so that should work now. Actually, no, it won't. There's one thing that we still need to do, and I'll just take this out. I don't know how that got in there, so let's save that off. Now, because we're using this HTTP client factory ultimately, or we're getting a HTTP client injected in, we need to make use of a HTTP client factory in order to do that. So this is the last bit of this section. It has been a bit longer than I had intended, so I do apologize, but Control B, and back over in our startup class, what we want to do in our configure services method is under our repository registration, we're going to make use of our services collection again, and this is where the HTTP client factory gets used. So we're going to add HTTP client, okay? And we're going to specify the interface. So in this case, it's going to be I command data client. So when we ask for an I command data client, we're going to give it a HTTP command data client. So this is us basically, this add HTTP client is making use of a client factory. And so when, let me just bring in the namespaces for these, and both should resolve them as they're in the same namespace. That's correct. So they have resolved. So back over here, when, I'll do a Control B, when our class constructor gets called, we're going to get a HTTP client injected in here that's going to be managed by a HTTP client factory. All right, so that was quite a long section. We need to test this now, so we'll do that in the next video, just to might have a cup of tea now, and then come back and we'll test this and make sure, test it locally, make sure that when we make use of this, and we'll have to put this into our controller in a second, we'll do that in the next video, when we call this service, we can actually send a message down to our command service, but we'll do that in the next video. All right, so still in our platform service, what we want to do is we've created our synchronous client, our HTTP synchronous client here. What we want to do is we actually want to be able to use it somewhere. And so where are we going to use it? Where does it make sense to use it? Well, it probably makes sense to use it from our platform's controller. So when somebody runs a HTTP post and we create a platform in our platform service, at that point we want to make a synchronous call, or do we, to our command service to make them aware, hey, we've just created a new command. All right, so we're going to put that code in here, and then we're going to test it. So just do a Control B just to give us a bit more breathing space. So the first thing we need to do is actually inject in an instance of our command data client into our platform's controller so we can use it. So I'm just going to take a new line for our injected parameters because it's going to get a bit long. So we'll still keep platform repo, we'll still keep IMapper, but now what we want to inject in is an I command data client, and we'll just bring in the namespace for that. So using platform services, sync data services HTTP, that's cool. And we'll just call that underscore command data client. And as usual, we need to create a private instance of it. So I'm going to call it underscore command data client equals command data client. There we go. And, oh, hang on. I should just create that. Yeah, there we go. That's right. There we go, that's better. So yeah, make sure the one that you're injecting has not got the underscore and the one that we are creating now has got the underscore. Okay, so generate a read-only field. And again, this pattern should be very, very familiar to you now. And again, coming back over to our startup class, because we've registered this here, we have this available to us in here as well. Okay, so we just come down to our post endpoint. And just before we return back with our created it route statement, I'm going to make a call to platform service at this point. Now, because things could potentially or conceivably go wrong, I'm going to use a try catch block because we don't want some horrific exception if that endpoint is down, for example. So I'm going to make use of the await keyword. I'm going to make use of our command data client. I'm going to send platform to command, and I'm going to pass in platform read DTO that we've got here. Okay. And that should be sufficient for this. And it's going to complain here, but we'll fix it up basically because this is not an asynchronous endpoint. And again, I will stress async in this context has nothing to do with asynchronous messaging. But before we do that, we'll just catch any exceptions. We'll call it EX, and then we'll just do a console write line with something of the nature of, and we'll use string interpolation, so we'll put $sign before the double quotes, and we'll say could not send synchronously. And there may be reasons for that. I don't think I've spelled that correctly, have I? Synchronously. That's right. Doesn't really matter, but for those of you who hate spelling mistakes, it probably is quite annoying if it is wrong. And then we're going to just pass in the message that we get from any exception. Okay, so hopefully this makes sense. So we'll try and send, use our data client to send our platform read DTO to our platform service. If it fails, we'll catch an exception. Now again, this is complaining because it's saying there is no await operator, but that's okay. So we can just put that in here, make it synchronous. But in order to do that, we have to specify it's a task really that's being returned. So task, and then close that off like that, and that should be okay. Not await, async. Okay, there you go. So async, await. And I don't think we have the threading namespace, so we'll bring in using system threading tasks. So this has now made this action result an asynchronous action result because potentially this command here could be long running. But again, to labour the point, from a calling perspective, it's still asynchronous messaging. So let's save that off. Let's bring up our command line. Let's do a .NET build. Looking good. We'll do a .NET run. And again, just to be, super sort of pedantic, you can see here that, I should say it here. It usually says it. There we go. The hosting environment is development. Okay, so because the hosting environment is development, it will make use of our app settings.development JSON file and pull in the right config for our command service endpoint. And actually, what we might do, I'm just going to stop running, and what I might do is up here in our startup class, what I might do is in configure services, I might just do a bit of an output just to say console write line, and we'll just say, just so we can see this printed to the screen, command service endpoint, and we will make use of our configuration object called configuration in this case. And we'll just specify this. So we'll have this printed out to screen, and because we'll probably do this quite a lot because we're going to be moving between different environments, so it's probably worth just printing out to our console what it thinks the endpoint is. So let's just start that again. There we go. So you saw there what it thought the command service endpoint is. There we go. So this is what it thinks the endpoint is, and indeed that is exactly what we should be using. Seeded data, all good. So that's our platform service up and running. Let's move back to our command service. Let's make sure that's running. Fantastic. And then what we're going to do is we're going to make a platform create request in our platform service, which should then call our command service. All right, so moment of truth. So bring up Insomnia once again. We're in our local development environment and we want to create a platform in our platform service. Okay, so let me just send this over. Looks like it created it, and we'll come over to our messaging, and you can see here within our command service we have an inbound post from our command service. Fantastic. And we come back over to our platform service, we have a message saying the synchronous post to our command service was okay. So that's all working rather nicely. But what I'm going to do, just to illustrate a point, I'm going to come back to our command service and I'm going to stop it. I'm going to kill it. Okay, so that endpoint is no longer there. And I'm going to do the same thing again, and we're going to see what happens. Okay, so we'll create the same thing again. So let's just click send. You can see it's taking time. Still comes back okay because it created the service okay, but you saw that took 2 or 3 seconds. Why did it take 2 or 3 seconds? Well, basically, if we come back to our platform service, you can see we could not send synchronously, no connection was made, blah, 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 which totally makes sense. But you saw how, as a consumer, we were waiting for that, okay? We were waiting for that response to come back. And you imagine there's a chain of those type of things or anything like that. Not a great experience. Nonetheless, we've achieved what we wanted to achieve. And just to recap, it's been quite a long section. We have created a test endpoint in our command service, and we've created a synchronous data client in our platform service that will call this test service in our command service synchronously. Cool, so we've established that that works. What we need to do now is put our platform service into Kubernetes and then wire up these 2 services using cluster IP addresses. So we're going to do that next. All right, so let's just do a quick sense check again of where we're at and what we've done. So we have our platform service running in Kubernetes, and we have our node port set up. We do not yet have our command service running in Kubernetes, but we have it running locally, and we had established connectivity between the 2. That's cool. So in this section, what we want to do is, first of all, get our command service up and running in Kubernetes, and then we're going to create cluster IPs for each of our pods so they can talk to each other. So really the first thing we need to do, the first step of getting our command service into Kubernetes is packaging it as a Docker image and pushing it up to Docker Hub. So we're going to do that now. So let's just make sure we're in the right space. We want to be in our commands service. So we're here, so we're in commands service, and you can see here we're in the right space. So do a quick clear the screen, and what we want to do is create a Docker file. So in the root of our commands service project, we're going to right click, new file, and I'm going to create a Docker file as we did before with our platform service. Now, all I'm going to do is come back over to our platform service and copy out the config from our platform service Docker file, because it's basically effectively exactly the same, bar one small change. All right, and that's down here, that's the entry point. So rather than it being platform service DLL, it's going to be command service DLL. Now let's just double check. In the bin folder, you want to make sure that the DLL commands service is matched here. It's exactly the same thing. I actually made a mistake in one of the other recordings of this video, and I got this name wrong and it caused all sorts of issues. So just make sure that you have the right entry point, and we'll save that off. Okay, and then as before, we'll do a Docker build, and we'll tag it with your Docker Hub ID, and then the name of the service, command service. Don't forget the build context at the end. All right, so we'll go away and build that. Should be relatively quick. Fantastic, and then we'll push it up to Docker Hub. So get rid of the build context, get rid of the T, and we'll just type in push, and this will push this up to Docker Hub so that when we create our K8s deployment for our command service, it has an image to go away and pull down. So we'll just let Docker do its thing and push that image up, and then we'll come back and we'll actually test and make sure that our Docker image is actually running as well. I probably should have done that before I pushed it, but we'll wait, we'll let the push finish, and then we'll test and make sure that it actually runs up okay. Now interestingly, you can see here that it's saying layer already exists. So because it is aware of layers for this image elsewhere, it doesn't have to push the whole thing back up. Okay, so that's pushed up. Now before we do anything else, I should have done this before I pushed it. We're going to do a Docker run. So Docker run, we'll specify an external port mapping to an internal port mapping, which you should be familiar with now. I'm not going to run it in detached mode because I actually want to see the output when we run it. So just the name of the service. Okay, so binary thistle command service. Let's run that up. It's cool. So it's run up okay. It's started on port 80. We're not getting any errors. So that all looks pretty good to me. So what we might do is come over into here and we can see that we have a command service running. So I'm just going to stop that from here. And we get our command prompt back. So that all looks good. So in the next section, what we're going to do is we're going to update our platform's deployment file to include a cluster IP service, and we're going to create an entirely new commands deployment file that also includes a cluster IP service. So we'll do that in the next section. All right, so let's come over to our K8s project. And here we have our existing platforms deployment. Now that's not actually going to change. That's staying exactly the same. But what I do want to do is come underneath here and add in a definition for our cluster IP service. Now you could put this into a separate file if you want. I like to keep it in this instance in the same file, as the two things are really very closely related. All right, so we specify an API version, and this time it's v1. So this will look very similar to the node port stuff that we did a bit earlier. The kind is a service. And then metadata is basically the name of our service, effectively. So we'll specify name, and I'm going to call this platforms cluster IP service. These names get quite long, so you've got to really check your typing. And I guarantee you will make a typo at some point throughout this course. So just be really, really meticulous with your spacing and with the naming of your services. And they have to be absolutely exact. If you're one character out, as has happened to me many times, nothing will work. So you've really got to double check. And if you do run into trouble, just download the config file from GitHub and you should be okay. Anyway, so we've specified the name of our cluster IP service, and I'm just going to specify what type it is. And it's of type cluster IP. Capitalize that, and then selector. Tab in, app, and we come up here and we actually pick the name of our template, which is platform service in this case. I'll just make sure I've not copied too much space there. There we go. I'll paste that in here. Again, you've got to get this stuff absolutely correct. We'll back out and then we'll define our ports. And then it's an array. So we'll give it a name. And again, I'm going to give it the same name, platform service as well. Tab in, protocol is going to be TCP. Port's going to be 80, and target port is also going to be 80. And that's it for now. We will add another port onto this for when we come on to doing gRPC, but for the moment we're just using plain old HTTP, so this should suffice. So our actual deployment hasn't changed yet, and we're adding a new cluster service IP into that. So let's just save that off for the moment. We're not going to apply that yet. And then we're going to create a new deployment for our commands service. So right click in here, new file, and we'll call this commands depl.yaml. Okay, and what I'm doing, I'm going to come in here and I'm going to copy all of this. And I'm just going to do a bit of a replace for our command service. Okay, so let's just work our way down from the top down to the bottom and replace the things that we need to replace. So the first thing we're going to change is the name of our deployment. So rather than it being platforms depl, it's going to be commands. The name of our service is going to be command service. And maybe we just come back over to Docker Hub and we just take a quick look at, just double check the name of our service. So it's command service, not plural, okay? So command service. And I'm going to copy this because I'm going to replace it everywhere. I'm going to push it in here. I'm going to push it in here. And I'm going to push it in here as well. Okay, so binary thistle, command service latest. Let's come down to the cluster IP for this service. And again, we're just going to change this. Instead of platforms to commands, cluster IP is okay. And I'm just going to change the selectors to what we already had. There we go. That all looks good. So if I just highlight this, we should have these same things highlighted throughout the rest of the file. And we'll save that off. Okay, that all looks good. Okay, so just to reiterate what we have done, we have built our command service as a Docker image and we have pushed that up to Docker Hub because we need that for our deployment. And we've now updated our platform's deployment to include a cluster IP service, which has not yet been deployed. And we've created an entirely new commands deployment that contains the deployment for our service and also cluster IP. So in the next section, we're going to run both of these deployment files to get everything up and running. But just before we do that, there is one little bit of config we need to pop back into our platform service just before we do that. So we'll do that next. All right, so I was talking about we need to make a bit of a change to our platforms service config. So back over in platform service, we need to know where our command service resides. And this is one of the problems of synchronous data services. If you're doing it this way, you need to know where all the endpoints are. And so we've created a config entry in our app settings development JSON file that tells us where we can find the command service in a development environment. And that's all cool. But when we deploy into Kubernetes, it's an entirely different environment. It actually runs in production. So this bit of config, number one, is not going to get picked up. And even if it did get picked up, it's going to be incorrect anyway because the command service is not going to be running here. It's going to be running somewhere else. All right, so the first thing we need to do is create another settings file just for production, just for our production settings. So I might just clear down a lot of this stuff because it's getting a bit busy. And come back over into the root of our project. I'll just minimize some of this to give us a bit more room. And we're going to create a new app settings file in the root of our project. So new file, app settings, .production.json. Okay, and so these are the settings that are only going to get picked up in a production type environment. All right, so we come back over here. I'm just going to copy this. Copy, and I'm going to come over here and create some curly brackets and create this as a top level item. So that's point number one, that's all cool. But where is our command service going to reside in Kubernetes? Well, if we come back over to our K8s folder and we look inside our commands deployment, we have created this cluster IP service for our command service. So again, come back to our architecture diagram because I think it's worth revisiting. Let's come back here. What we are attempting to do is get our two services to talk to each other via their cluster IP services. So really the endpoint from a platform service perspective, the endpoint it needs to reach out to is really the cluster IP service attached to the command service pod. Okay, so the name basically that we need to put in is this here, the name of our service. That is effectively the endpoint our platform service needs to reach out to. So I'm just going to copy that and come back to our platform service. And in our app settings production JSON, I'm just going to replace this here with the cluster IP service of our commands service. And I also need to specify the port. So the name of the cluster IP service, :port, and everything else should remain exactly the same. All right, so again, you know, a little bit kind of convoluted, but there's a lot of config involved in setting all this up. And again, you're probably going to make mistakes along the way. Don't stress if you do. I've made plenty. But the other thing to note here is because I've effectively changed our image now, created some new settings and app settings, Jason, we're going to have to repackage, rebuild our Docker image for our platform service and re-push it back up to Docker Hub. So let's do that now. Let's build it. And let's push it up. So I'm just doing up key, so Docker push binary thistle platform service. And it shouldn't take that long as we've only made a minor change. Now, going forward, you would probably want to extract the settings out of settings file in this way and not have to redeploy images to read in this type of stuff. But again, for this video, I've chosen to do it this way, just in the interest of time. But you can see this probably isn't a particularly efficient way of changing your settings, having to redeploy an image, but that's what we're doing here anyway. So once that's pushed up, what I'm going to then do is we're going to then apply our deployment files, the 2 files that we've run, and we'll run into another interesting concept when we come to doing that. So there we go, that's pushed up. So I'm going to pause here for a minute and then we're going to come back and we're going to revisit the 2 files that we've created, because as yet we've not reapplied them, and then we'll do our final test to make sure that we get our services talking inside Kubernetes. So we'll do that next. All right, so let's just do a quick sense check of where we're at. So let's come back into our K8 project. And I'm going to bring up our command line. I'm just going to clear that down. So the first thing, I want to just, level set on where we're at, because we've done quite a lot of work and it can get confusing. So let's do a kubectl get deployments. Okay, we only have one deployment up and running, which is our platforms deployment. Been deployed, it's all cool, looks good. If you do kubectl get pods, you can see we have one pod up and running, which is our platform service. So again, we've created these files, but we've not yet applied them. And then the last thing we'll do is we'll do kubectl get services. And you can see here we have this Kubernetes cluster IP, which is already there by default, and we have our node port that we created a few sections ago. All right. So the first thing I want to do is I want to apply our platforms deployment again. So quick directory listing, make sure we can see our platforms deployment file. And we're going to do kubectl apply f and the name of our deployment file. So let's do that now. And let's run that. Okay, now you can see a couple of things here. It's saying that the deployment has remained unchanged. Okay, and that's fair enough, because this part of the file, what's really referring to is the deployment here, the deployment we've actually specified in this file, and that hasn't changed. That's remained exactly the same. But what it has said is we've created this new cluster IP service, which all sounds great. So if we do kubectl get services, you should see we have this platforms cluster IP created, which looks good. But coming back over to our Kubernetes session, and pulling this over here, we have our pod running and we have our platform service running. What hasn't happened by rerunning that deployment file, Kubernetes hasn't gone up to Docker Hub and pulled down the latest version of our image that has our new configuration pointing to our command service. It's not done that. If we just come back over here and go into it, you can see that, it's not restarted, it's not done anything, whatever. So what we need to do is we need to force Kubernetes to refresh this image. Okay, so the way we do that is we come back over here and we'll just do a kubectl get deployments, just to get a list of our deployments again. I spelled that wrong. Yeah, there we go. So we've got our platforms deployment. We want to basically restart that or refresh that. So the way we do that, again, this is all in the cheat sheet, these command lines, kubectl rollout, restart, deployment, and then we just specify the name of the deployment. Okay. And then it says deployment apps platforms depl is restarted. And if we come back over to Kubernetes, we should see some things happening over here. Or Alternatively, rather than doing that, we can just do kubectl get pods. And you can see that we have a container that's running already, but we have this container that's now creating, which is the new container with our new image, with our new config, and it's creating. And eventually this running one, it will terminate once that one has started. So we just have one running now, which is good. And if we come over to Kubernetes and we have a quick look here, you can see one pod has died, and then we come over to our platform service. You can see here, the command service endpoint is here. So it's picked up the right endpoint, certainly, that we've told it to pick up. This is what it will be looking for when we hit the controller. It will then reach out to our platform service. But that won't work at the moment because we don't actually have our commands service deployed. So we'll do that now. And it's relatively straightforward. So back over in K8, let's just clear this out. We'll just do, again, kubectl get deployments. We only have one deployment, so we now want to execute our commands deployment. So again, we'll just do an up key. We want to apply our commands deployment this time. Okay, so kubectl apply -f commands deployment. And you can see this time, we didn't have a commands deployment at all, so it's gone off and created one, and it will pull down the image it has for that. And then it's created a cluster IP service for that as well. Fantastic. So if we do kubectl get services, you'll see we have our two cluster IP services, one for commands and one for platforms, which is good. And then if we do kubectl get deployments, up and running, both are up and running, and we'll do a kubectl get pods to see the health of our pods. And we have two pods up and running, a commands pod and a platforms pod. So that's all looking quite promising. Fantastic. So we'll just come over again to our Kubernetes instance. Let's make this bigger. And you can see we have a pod for platforms, a pod for commands, a platform service, and a command service. And we click on the service, it all looks like it's running okay. So that's looking pretty exciting. So final step here that we want to do is just test that that is working. So we're going to make a call into our platform service, a post request, and we're going to see if we are talking to our command service. So we'll do that next. Fingers crossed it's all wired up correctly and it's all working correctly. So we'll do that. Yeah, we'll do it next. All right, so let's get testing this. So to test, we're going to use Insomnia. So we're going to be testing purely within our K8's environment. And so all we have so far is the ability to get platforms from our platform service. So let's just run that and make sure that's still running okay. That's good, a good start. So what we want to do next is then create a platform in our service running in Kubernetes. So let's come down to our local dev, and I'm just going to copy or duplicate the create platform call, and I'm going to move that into here. Now at the moment we are using a node port, and again we're reliant on this port here in order for that to happen. So let's copy that, and we'll come down to here and we're going to paste that in here. Okay, so hopefully you remember that from when we were looking at node ports. We were just calling a create platform, but we're having to use this node port endpoint. And we'll just, again, we've only got 3 platforms in our platform service, so we're going to create hopefully another one. Now what we expect to see is that number 1, a platform will be created in our platform service. Fantastic. But more importantly, what we want to see in the logs of our command service is that it received that post notification, and if it receives that post notification, then we know that everything is wired up correctly, and we're really quite far down. We've broken the back actually of a lot of the Kubernetes networking stuff, which I appreciate is quite quite voluminous and quite boring. So fingers crossed, let's click send. Looked pretty good, it came back pretty quickly. So looks like we've created a platform in our platform service. Let's just rerun this. Fantastic, we have. And then the last bit we want to test is we want to come over to our Kubernetes session and just pull it over into the screen. And we'll take a quick look at our platform service first, and we should see that it sent some stuff over to, we've done a couple of calls that was getting a platform, so if we move a bit further up, sync post to command service was okay. So it called the command service okay, it didn't get an error, which is fantastic, it's looking pretty good. And then we come into our command service, and you can see here that we got an inbound post from our command service. So it looks like everything is working very well. Now, the only thing you will notice is that we get this warning around HTTPS redirection. So nothing really to worry about, but if we come on into both our services or either of our services, let's pick our command service and come into our startup file. You'll see down here in configure that we have this use HTTPS redirection. That's what's causing that error. Now, one of the things I decided to leave out of this course was introducing HTTPS, I think I've said this already, into our internal Kubernetes cluster. We're not going to use that. So what I might do, just to get rid of those warnings, I might just comment this out. And of course, as soon as we comment it out, it means we've got to redeploy our stuff back up to Docker Hub. But again, I'll leave you to do that in your own time. I'm not going to do it in the video. This is relatively benign at this point in time, so I'm not too bothered about that. So I might do that in between now and the next video. I might push my images back up to Docker Hub. I'm not going to include it here. If you choose not to do that, it's not a big issue. So I'm going to comment it out of our command service, and then I'm going to comment it out of our platform service as well. So over in startup, I'll do that as well. And in between now and the next video, I'm going to build these images and push them back up. And of course, you would have to do the rollout restart thing to get Kubernetes to pull down the latest version, but I'll leave you to do that at your leisure. And if you choose not to, it's not a big deal. It just means that you'll still get those HTTPS redirection warnings. Fantastic. So that's a big milestone that we've got over. What we're going to move on to next is we're going to move away from using the node port, and we're going to move into using a more productionized mechanism to get into our services, and that's when we start talking about the Nginx ingress controller. So we'll start to move on to that next. All right, so let's just do a quick architecture review just to see how we're doing with our Kubernetes build. Let me just find the right, there we go, the right slide. So we have basically got to this stage here where we have a node port, we have our two services running in pods, and we have our cluster IP services wired up so they can talk to each other, which is fantastic. But now we want to stand up what's called an ingress Nginx controller. And as a result of standing that up, we'll also get this load balancer service as well that will allow us to get external traffic in. Now, this is kind of going into more detail about how Kubernetes works. We're going to go through it all step by step, but I'm not going to dwell too much on it, okay? Because we're actually going to be reliant somewhat on an external YAML file that's going to set all this up for us. And really the only thing we're going to end up doing is writing the routing config for this gateway, for this ingress Nginx controller, and the rest of it's kind of taken care of by another GitHub project actually, which we'll take a look at now. So actually that's probably a good segue into that. So let me just come over to Google and let's pull it onto my screen. And if you search for ingress Nginx, be careful because there's a few very similar repositories, but this is the one we want here. So it's GitHub Kubernetes /ingress Nginx. Now, don't worry, we don't need to really do too much with this. If you scroll down to the Getting Started document, this is really what we want. And this is telling you how we can install this ingress Nginx controller. And we have all these different providers. So if you were running on Google Cloud or something, then you would pick this one, or AWS, you would go with this one. We're using Docker Desktop. So this is all we need. Okay, so we're going to copy this here. You can see the kubectl apply f command that you've been very comfortable using for the last few sections of the video. But this time we're going to specify a URL to where the YAML file exists. So what we might actually do is let's just copy the URL. I can do that properly, copy it, and I'll put it into another browser window, and you can see, and you can probably suggest you take a quick look at the contents of this, but you can see It's pretty big, it's pretty long. I'm glad I don't have to type it out, and I'm sure you're pretty glad you don't have to do it either. But it's still worth going through and having a quick look to make sure you have a sort of understanding of what it's trying to do. But by and large, yes, it sets up this basically an API gateway that we can, route into. So enough of that. I'm going to copy the whole thing now, the whole kubectl apply command. In fact, we can probably just tick this little thing here. That's good enough. And we'll come back over to a command prompt. Let me clear this down. I'll paste this in. And there you go. It's kind of gone through and basically applied everything. So let's take a look and see if we can understand what it's done. So if I bring over my Kubernetes session and go back to the list of running services, you can actually start to see there's a pod here, Ingress Nginx pod here. There's a couple of pods actually, and these will work through for a bit until the deployment has settled down. So some of these things will create, recreate, and then destroy themselves. So let's come back over to our command line. I'll do CLS, and again, we'll take a look. We'll do kubectl get deployments. Now, something kind of strange going on. We can only see the deployments that we have done, our commands deployment and our platforms deployment. What about if we do get pods? Do we have any joy there? Not really. We see our two pods that we have created, our commands pod and our platforms pod, but where's all this Ingress Nginx stuff? Well, again, a bit more of a detailed Kubernetes concept, but Kubernetes works on this concept of namespaces. In a similar way that we've got namespaces for our classes and stuff, Kubernetes works along the same line. So we are working within the default namespace for our project. So we've not really covered that as yet, and I'm not really intend to cover it in too much more detail, but the stuff we've created for Ingress Nginx is in a completely different namespace to our application. So just coming back over to the cheat sheet, you can actually look at all the namespaces that we have. So kubectl get namespace. And you can see here we have default, which is kind of where we are working in, and then we have this, we have these kube namespaces as well, which I'm not really too interested in. And then we have this new Ingress Nginx namespace that's being created as part of what we've just run. So we can look at the pods in that namespace by doing kubectl get pods, and again this is on the cheat sheet, namespace, and then equals the name of the namespace, which in this case is Ingress Nginx. I'll do that. Now I might actually make sure that I put 2 dashes in there. There we go. So that's 2 dashes, not 1 dash. And the cheat sheet is correct. I just was misreading it. And you can see here that we have a couple of, well, one running pod basically, which is now our Ingress Nginx controller. And these two things have basically completed. They're no longer running. And that's what I was talking about with these pods that kind of create themselves and then destroy themselves. So that all looks relatively good. So let's come back to Kubernetes, and you can see here, yeah, we've got a couple of ghosted pods. So I might just get rid of these, remove them. Don't need them. And we've got enough going on our screen without having all this extra stuff running. Okay, cool. So we've got a pod for Ingress Nginx controller, and we have a controller, the actual controller itself, and you can go in and have a look. And it's basically running on Nginx, which is similar to Envoy, which is basically used a lot as a gateway type setup. Fantastic, so that looks good, but at this point in time all we've done is set that gateway up. We might also take a quick look at networking, get services. And you can see in a similar way that we've got the services that we have set up for our namespace, but we could get the namespaces for Ingress Nginx. And I dread to think what it's going to show us, but let's take a quick look. And you can see here we've got a load balancer, which was created. It's another service type, and we have another cluster IP service actually as well that's being used there as well. All right, cool. So again, we don't really need to worry too much about that. That's all been set up for us automatically. What we do need to come on to doing now is to create the routing file that this controller is going to use to route to our two services. So we'll do that next. All right, so back over in our K8s project. So make sure you have your K8s project selected. I'm just going to clear the terminal screen, and actually I'm going to get rid of it for the moment. We don't need it just yet. And I'll clear down these other two files. So we're going to create yet another YAML file in here. So right click, new file. And I'm just going to call this ingress-srv.yaml. And this is the routing file that the Ingress Nginx controller is going to use to determine how to route to our services. So it's really quite important. All right, so we're going to type all this out. I'm going to go slow. Don't want to make too many mistakes, otherwise it's going to be very, confusing and difficult to debug. So specifying an API version. This time it's slightly different. We want to specify networking.k8s.io/v1. So let me just double check that. API version networking.k8s.io/v1. Perfect. I'm going to specify a kind, and this time it's an ingress. I don't want all that autocomplete stuff, so I'll just type it in. Make sure I type ingress correctly though, so it's an ingress. Oh my goodness, I don't want that. So yeah, kind is ingress as opposed to deployment or whatever. Fantastic. And then we specify some metadata. Again, we will specify a name, and I'm just going to call this ingress SRV, and then some annotations. And we have two. And I tell you what, I might actually copy these in from my notes because they're just going to be very subject to typographical errors. And these are just a couple of helpers really that we're specifying that we want our controller to use. Okay, so it's talking about regular expressions, and yeah, we're using this ingress class for Nginx, which is the gateway that we're using. All right, so again, the code is on GitHub. So again, if you don't fancy typing this out, and I don't want to type it out on the video in case I make a mistake, and then it's just a whole nightmare going back and fault finding. So I've just copied those in. Have a go at typing them out, or you can just go to GitHub and do what I did there and copy them in. Fantastic. So we're going to come back under the main route or indentation layer. So underneath metadata, kind, and API version, we're going to specify the main spec and the rules of our routing rules effectively. So indent rules, fantastic, indent again, and this is an array. So the first thing we're going to specify is our host. Now, like a lot of these gateways, they actually require a host name. They don't like localhost usually. They don't like IP addresses usually. And I did a whole video on the Envoy controller. It had the same kind of issue. Well, maybe it's not an issue. It has the same constraint. So you have to specify like a domain name. Now, we just want to really route to our loopback address or a local host address. I know they're slightly different, but basically our local machine. But we do need to specify a proper domain name. So I'm just going to specify one here. I'm just going to call it acme.com. And we're going to have to update our hosts file, our local host file, to reflect that acme.com actually redirects to our local address. Okay, so we'll come back and we'll do that in a bit, but just bear with me for the moment. I'll just put that in here. Now you can put anything you like in here. Just remember what you put. If you're following along, I suggest for simplicity, you just put in acme.com like I have done here. All right, under host, we're going to specify it's a HTTP based routing rules. So again, HTTP is directly under host. And then we're going to specify an array of paths. Now this config, it doesn't get much, there's maybe about another 10 lines involved, so don't freak out too much. It's not going to get too much bigger, but it is quite a deep config file, and you have to be, again, I keep saying it, really careful about your indentation, making sure that you've indented correctly, because it can catch you out. So specifying paths, and there I've actually made a mistake myself here, so it's paths like that, and you can see it was actually complaining, so paths is indented under HTTP, and under that we start to specify the individual paths that we want, so singular path. All right, so the first thing we want to attempt to route to is our platform's controller, a platform service. So the way we do that is just by specifying the route on top of the base URL. So anything on top of acme.com, would be, in the case of platforms, would be API platforms. And then we specify a couple of other attributes. Path type is prefix. And then we specify something called the backend, and you can probably guess what that is getting at. Is what service basically are we trying to attach to here. Okay, so the backend, we specify the service, and we specify the name. And the name of the service basically is, if we come over back to our platforms deployment file, it's basically the name of our cluster IP. Okay, so we're going to copy that. So again, platforms deployment file, our cluster IP service, that is the name that we are going to put in here, and that's where we want to kind of direct this backend to. All right, and then port, tab in again, number is 80. Okay, so that's putting in a single route to our platform service at this path on port 80. All right, that all looks correct. So I'm going to create one more path, but this time for our commands service. So I'm actually going to type it out, because sometimes cutting and pasting can be more trouble than it's worth in a YAML file like this. So again, make sure you're specifying your next path as part of this paths array under this minus sign here. So we're going to specify another path, and it'll get us used to doing this kind of stuff anyway. So this time the route is API /C. Now again, this is the whole reason I put this C identifier in the route to our command service, because it needs to be different from this, otherwise we're going to run into some issues. So again, platforms, path type, prefix, and then we specify the backend in a very similar kind of way. We tab in, specify the service, we give it the name. This time it's the commands cluster IP service, so we come back over to our commands deployment file and we come down here. We want this name, the name of our cluster IP service. So you can see this stuff is quite horrible, and again, the video I did on Envoy, to be really honest with you, I didn't really enjoy it. And I'm not particularly enjoying this either. I don't really like this stuff, to be really honest with you. For me, it's kind of configuring API gateways. I don't love it, to be honest with you, and it's so subject to error that yeah, it's not my favorite thing, to be really honest with you, but it's a necessary evil in this case. And again, we're specifying port 80. So I think that looks okay. There's no warnings in the actual file itself by the looks of it, so that's all good. I think we're ready to go. So I'm going to save that off, and then all we need to do is just run the kubectl apply command, which we'll do next. But before we do that, I'm going to go into my host file and I'm going to make sure that we have an entry for acme.com, but I'm going to do that in the next video. Alright, so we want to update our host file now. Obviously, the host file is in a different location depending whether you're running on Mac, Windows or Linux. I'm running on Windows obviously, so I'm going to browse to that location. I will put a link to where you can find your host file on those two other operating systems, but you can probably, to be honest with you, just Google that yourself. The result is basically the same. So I'm just running, as you know, obviously VS Code, so I'm going to just open my host file from within my K8's project. So file open. Now on Windows anyway, you have to basically open it as an administrator, otherwise it won't let you save the file. Or you can save it as administrator, which is what I'm going to do here. So open file first of all, and the location on Windows is on the C drive. It's in Windows, it's in System 32, drivers, etc, and then there's a few, what look like a few different host files, but it's this first one here, the one that just says hosts, and I don't believe there's an extension, so we just open that up. And we can see here that there's a few entries in here already. Now what I want to do is I want to put in entry for acme.com or whatever you've put in your ingress service file, and I want to just direct it to 127.0.0.1. And you can even see there's some stuff in here that's been put in by Docker Desktop as well to assist with networking. Okay, I'm just going to put this in here, and I'm just going to put in acme.com. So what effect this has is basically whenever we type acme.com into our web browser, it's actually going to look here first before it goes and does any, DNS lookup elsewhere. So we're kind of hijacking acme.com. So just remember, of course, that you've done this in your host file, unless there is a site called acme.com that you visit frequently, maybe pick something else. So I'm going to save that, and I'll probably get the warning. So here we go. So it's failed to save, insufficient permissions. So I'm going to retry as admin. And I've just got a pop-up on my other screen saying, do I want to do that? And I've just said yes. Cool, so that should be as good. But what I'm going to do, just because I'm paranoid, is open it up again, just to make sure that that save took. Because I don't want to get through to deploying our changes and then find out that something went wrong. So Windows, System32, drivers. There we go, that's the wrong one. Drivers. And etc. And I'm going to open my host file again. And yeah, the change took, so that's fine. So I just want to double check that that is there. All right, cool. So then all we need to do, as we've done many times before, is basically run or apply this ingress SRV file using a very familiar language so far. So just make sure you're in your K8s project folder. We'll do a listing and make sure you can see your ingress SRV YAML file. So again, it's kube ctl apply f, and I'm just going to apply this config. And there we go, we've got this ingress networking K8s.io created, which looks good. So the moment of truth, we want to try and test this now in Insomnia. And again, just coming back to our architecture diagram, I will just show us where we hopefully have gotten to. We want to try this thing here now. So external coming in through this Nginx load balancer, it's going to hit our ingress Nginx controller, and then depending on what route we put in, it's going to route off to either one of those. All right, so fingers crossed, this is a big moment for us. Now, again, what I'm going to do here is, yeah, we're actually running in the K8s environment. So again, yeah, I might want to specify something different here. So what I might do, because this is using the node port stuff, so I want to differentiate that. So I might just rename this and just call it platform service node port, just so I know those are the node port requests, which you may want to continue to use for fault finding purposes. So I'm going to close that down. Actually, these aren't in here, so we just put these in here. That's better. And I'm going to create another folder in here, new folder. I'm going to call it platform service, and I might just call it Nginx, which is really our gateway proper. All right, so I want to copy this or duplicate it, get our platforms and move it up here under this. So instead of routing to localhost 30,407, if we just put in acme.com here and make sure we spell it correctly, it should route off to our platform service and pull back all our platforms. So drum roll, there we go, fantastic. So we've now set up successfully an ingress Nginx controller. Now, we can't quite test our command service yet because the only controller action we have is that stupid post command. Well, I suppose we could test that really, but I'm not going to do it here. We'll come on and we'll check that when we put in some get actions that we can route through to our command service as well. But I'm fairly confident at this stage, famous last words, that this is looking pretty good. Fantastic. So that's probably most of our networking type stuff done now. We're going to do a few bits of repeated setting up of cluster services and stuff, but by and large, in terms of new concepts, we're done. We're done with new concepts around Kubernetes networking, so it's a good place to be in. So we're going to start to move on to what I think now is a lot of the more interesting stuff. So then the next section, we're going to set up our SQL Server for our platform service, along with some persistent storage, and we're going to get all that hooked up. And then beyond that, we're going to move into using RabbitMQ and all that really interesting, exciting stuff. So yeah, we're done in this section. Next section is going to be setting up SQL Server. So yeah, we're going to create our SQL Server now. So let's just check to see where that fits in terms of our Kubernetes architecture. So we've got to this stage now. We just created our ingress Nginx controller in our last video. And now we're going to set up a dedicated SQL server just for our platform service. And along with that, we'll create a cluster IP address. Now, something new that we've not encountered yet is another new concept. This is the persistent volume claim. Now, all this is something that we will put into the deployment file for our SQL server that basically, as the name would suggest, stakes a claim to some physical storage, in this case, on my machine. So just staying on that theme for the moment, if we do a kubectl get storage class, make sure I spell it correctly, we have one storage class. So what's a storage class? Well, there's three concepts really when you're talking about storage. Well, three basic concepts you need to understand. The first one, and really as a developer, the main one you need to understand is the persistent volume claim, which we're going to create. Then you have something called a persistent volume, and then you have this thing called the storage class. So thankfully, all we need to create is the persistent volume claim, and that will use our system defaults, and ultimately we'll use this storage class, which is effectively, in our case for Docker Desktop, just our local file system. If you were using a more enterprise deployment of Kubernetes, say in Google Cloud, you would have to set up all of these things independently, and that's when you start to move into this more administration type role rather than the developer role. As a developer, all I'm really interested in is making a claim to some storage. Other than that, don't really care, to be honest with you. So I'm going to leave it at that, and we're going to move on and create our persistent volume claim in our K8s project. So yeah, in our K8s project, just right click anywhere. I'm going to do a new file, and I'm going to call this local, as it's going to be on our local disk, local pvc.yaml. So local persistent volume claim.yaml. Let me get rid of the terminal for the moment. And API version, and it's going to be v1. Make sure we put the colon in the right space. And the kind this time is a new kind. It's persistent volume claim, and I want to get the persistent volume claim. I don't want to type that, but I don't want all this default stuff. So let's, oh goodness. Actually, I can probably take most of this. I just don't like doing too much auto-generated stuff because it kind of gets a bit lost on everybody. So yeah, let me take this out. That's why I was getting confused. Okay, so API version v1. The kind is persistent volume claim. We are going to have metadata, and we're going to give it a name, and I'm going to name it MSSQL-claim. So Microsoft SQL Server claim, if I can spell claim correctly, that would be useful. And then spec, we're going to specify how this persistent volume claim is made up. So the first thing we need to specify is something called an access mode, or access modes, and it's an array. And I'm going to specify that it's read, write, many. So we want it to read, we want it to write. Then the next thing is our resources. And really this is where we're staking our claim to the storage resources or the persistent resources that we want to use. And it's resources, requests, and then storage. Typing's really starting to suffer now, and I just want 200 megabytes. I don't want a huge, massive disk size, so that should be fine for us. Now, this looks rather sparse, and indeed it is, and you can obviously specify more things in here. But for now, if we just leave it at that, Kubernetes is smart enough just to use the defaults, which will give us access to our local file system. So save that off, and then bring up your command line. We'll just clear this off, and we'll do a listing just to make sure we can see the local PVC file. And then as usual, it's just kubectl apply f, and then the name of our file. I'll paste that in there. And you can see here that our persistent volume claim has been created. So if we do a kubectl get PVC, you will see that we have a persistent volume claim created. Status is bound. We've got our access mode, which is read and write. We've got our capacity, and we've got our storage class here, which is host path. And if you remember from when we got our storage class, that is what our storage class is, host path. It uses it by default. So that's it really for the persistent volume claim. The next thing we need to set up just before we actually go on and create our SQL Server is SQL Server, when we set it up, will require a system administrator password. Now, again, for a lot of the config I've got in this tutorial, a lot of it is just stored in config files, which is not best practice, but again, in the interest of time, that's what I've done. But here, what I'm going to do, just to show you how you can use something called secrets, I'm going to actually create the SQL Server password as a secret in Kubernetes, and we're going to pull that in via a config file. So it kind of removes this idea that you're actually storing sensitive information in config files, which you generally don't want to do. So we'll do that once, and then we'll move on to actually setting up our SQL Server. All right, so let's just clear the screen here. And what I'm going to do here is I'm actually just going to issue this command, obviously, at our command line. I'm not going to create a file because, again, it would defeat the whole purpose of having something that's secret if you actually put it into a file, because then you just have the same circular reference of bad security. So we're just going to issue this at the command line and not store it anywhere. So it's actually a bit like user secrets. If you've used user secrets with .NET development, it's kind of similar concept to that. In fact, very, very similar to that. So at our command line, we're going to use kubectl, obviously. We're going to create a secret of type generic, and we're going to call it MSSQL. And we'll make use of this MSSQL name in a bit when we actually come on to creating our SQL Server. Then dash from dash literal, and then we specify basically a key value pair for the key and the value. So the key in this case is going to be SA underscore password, all capitals, and the value is going to be our password. And I'm just going to use, well, you can use whatever you like. I'm going to use this. So let me just check the spelling. I've checked everything is spelled correctly. So kubectl, create secret, generic, MSSQL, dash from literal SA password. That looks good. Okay, so we have our secret created. Fantastic. So we just make sure that we remember these two things here, this name here, and also the key that we defined. So now we're actually going to make use of this when we come on to creating our deployment for our SQL Server. So we'll move on and we'll make use of our secret as well as our persistent volume claim, and then we'll stand up a new instance of SQL Server. All right, so here's the main event of this section. We're going to create a deployment for our SQL Server. So I'm just going to get rid of our terminal because, believe me, we're going to need the room. This is it's actually the longest file that we're going to write, the longest deployment file by a mile that we are going to write. So in our K8s project again, right click, new file, and I'm going to call this MSSQL -plat, as in for our platform service. It's going to be dedicated to that. depl.yaml. All right, so we'll specify an API version of apps v1, and I need to be really careful what I type here because there's a lot of stuff going in, so I'll double check every line as I type. The kind, we've come across this before, is a deployment, and I don't really want that, so I'm going to just type it out, deployment. And the metadata, we're going to supply a name, and that is going to be MSSQL depl. So that's really the name of our deployment. So when you do kubectl get deployments, this is the name that will come up. And if you wanted to destroy this deployment, this is the name that you would refer to. All right, so nothing that we've not seen before. And again, we're going to come on and define the spec. So tab in. We're going to define number of replicas, so 1. And then we're coming on to the usual selector stuff that you've seen quite a few times before. I'm going to use some match labels. And then we're going to call our app MSSQL. Just MSSQL. Okay, oh my goodness. Autocorrect is quite annoying sometimes. Okay, so bring your cursor back under the selector, and we're going to define the template this time. Specify some metadata. You can probably tell I'm not a huge fan of YAML files. The only thing I do like about them is that you can put comments in, which you can't typically do with JSON, so that is their one saving grace. So anyway, template, metadata, labels, app, again, is MS SQL. So you've seen this selector template thing before. Okay, new line, and bring your cursor underneath the metadata, underneath template. Again, be really super careful. I can't really stress it enough. Be super careful about how you type this stuff in, because one mistake and it's game over. So we're going to specify the containers that we want, and again, this is an array. In this case, we are just creating one. So I'm going to give it a name of MS SQL, and then bring the cursor under the name. We're going to specify our image, and this is where we specify the Docker image for our SQL Server. So it's mcr microsoft.com/mssql/server : and I'm going to use the 2017 version of SQL Server, the latest version. Then I'm going to specify some ports, and we're going to specify the default SQL Server port, which some of you may know is 1433. So bring your cursor back underneath the ports, and then we're going to specify some environment variables, and this is where we're going to kind of inject in our secret along with a few other environment variables. So minus sign, we'll give the first one a name of MSSQL PID. Tab in and give that a value of Express. So basically that's saying we want to use the Express version of Microsoft SQL Server as opposed to the developer edition or whatever. And this edition is of course free. So we're going to create another environment variable, give it a name, and this one we'll call accept EULA, and the value is going to be yes. Now that's just accepting the license agreement as per, you know, Microsoft's usual kind of way of doing things. And then we're going to specify one more, and this is where our system administrator or our SA password comes into play. So the name is SA_password. And just as a matter of interest, if you were just running SQL Server, and I've done a few videos on this, if you were just running SQL Server in Docker without using Kubernetes, you actually have to pass in some, well, exactly the same environment variables as part of that. So if you Google SQL Server Docker, you'll actually see some very similar setup required just to run SQL Server as a container. So again, we're just doing that here obviously, but albeit in a Kubernetes deployment. So we're not going to specify an actual literal value, because again, that would negate the whole point of setting up a secret. So we're going to use this thing called value from. And where are we going to get our value from? We're going to get it from a secret key ref. Okay, take a new line, tab in again. What's its name? MSSQL. And again, well, if I bring up my command line, I should be able to, it should still be there, I think. It's basically this thing here, okay? The name that we gave it here. And then the other one is, here's SA password. So again, that's where SA password is coming in. Here's our key here. All right, so that's all that's pulling in. And the key we have to specify here is SA password. Okay, so the name of the environment variable is SA password. The name of the key that we gave it is SA password. Let me just highlight that. That's the same. That's cool. Okay, and that's it for our environment variables. So we need to take a new line, and we need to take our cursor underneath the env. Okay, and here we're going to specify volume mounts. And we're going to give it a mount path, and this is just the mount path of when SQL Server runs. Now we're actually running, this image here is the SQL Server running in Linux, so the mount path is going to be like a Linux-based path, and it's just really going to tell us where our database is going to reside, where our data for our database is going to be. So it's var opt mssql/data, and we'll give it a name of mssql_db. Not DV, DB, B for Bravo. All right, almost there. Well, almost there for this part of it. We've still got the networking stuff to go. So we're going to bring our cursor out underneath our containers. So again, Visual Studio Code is quite nice. It does give you the kind of line marker to kind of help you not go too cross-eyed. And I'm just noticing here under volume mounts, I need to bring this back like this, and I need to bring this back like this. That's better. And volume mounts is underneath our ENV. That's correct. So yeah, this stuff is pretty painful. I will not kid you. I don't particularly love it. Anyway, okay, when I auto-generate it, it's actually doing that for me, but I'm going to leave it like that. Okay, so MSSQLDB is the name of this. And this is really where we're setting up our persistent volume claim. Persistent volume claim, claim name. If I come back over here to our persistent volume claim, it's this thing here. This is the name that we want to, or the claim name that we want to use. So we'll come back over here. Claim name is that, okay? So you'll notice this pattern when you're doing these deployments. You reference other objects that you've created elsewhere, so you just have to make sure that you're creating the right thing. So I think that all looks correct. I mean, obviously when we run it, we'll find out whether it's incorrect or not, but I'm just checking it against my notes to make sure it's correct. Yeah, so I mean, it's kind of done some indentation that I've not used in my notes, but I think it will be okay. I think that should be okay. All right, we'll find out if not. So that's it for defining our SQL Server. You'll be very pleased to hear, but what we want to also do is create a cluster IP address so it can talk to everything else within our cluster. So down here, I'm going to take a new line. Now, as I don't particularly want to do too much more typing, I'm going to copy the cluster IP address spec from one of our other deployment files. So I'm just going to come over to our commands deployment, and I'm going to come down to where we specified the cluster IP address for that, and I'm just going to copy it. Now, obviously, we have to change some settings in it, but that's okay. That's preferable to typing it all out again. So at version v1, the kind is service. The name we're going to change, and I'm going to call it MSSQL cluster IP -srv. So the spec type is cluster IP. The selector, and again, this is where we want to actually select the thing that it's going to network, is basically this here. So we want to copy MSSQL and put that in here twice, basically. So I'll take this out, I'll paste that in, I'll take this out, and I'll paste that in. Protocol is TCP, but the port and target port are both going to be 1433, which again is the default SQL Server port. All right, so that's good. Now, we could leave it at that, but I actually want to be able to access this SQL Server from my desktop. I want to be able to kind of drill into it directly. Now, we can't do that through our Ingress Nginx controller. We could create a node port. I think that would probably work, but there's another service that you can create called a load balancer. We've kind of already sort of seen it with part of the Ingress Nginx stuff. So we're going to actually create a load balancer service, which does similar stuff actually to the node port. It will allow us to actually directly access this. So let's go through and do that. Now, I think I can probably copy this, and we'll just change the relevant bits and pieces as we need to. So again, API version 1, it is a service. We will give it a name of MSSQL load balancer. Now, I don't have this on our architecture diagram. You might go, where is this on the architecture diagram? It's not on there. I deliberately left it off because I didn't want it to become too confusing. And we're actually, when we create a RabbitMQ server, we're going to do something very similar with it as well. We'll create a cluster IP and also a load balancer that we can use to access it. But again, I didn't want to put that on our diagram because it would it'd get a bit too confusing. Now, you don't have to do this. This is somewhat optional, but I think it's probably going to help us out, to be honest with you. Anyway, back to this. In our spec, we're specifying that it's a type load balancer. The selector is the same, MSSQL, and ports, we don't need to give it a name, so we'll take that out. We need to put in the fact that this is an array. Now, if we're specifying more than one port, we would need to give it a name, but we don't in this case. So ports, TCP, and again, we'll leave the ports exactly the same. That should work for us, I think. All right, so let's just do a bit of a review. This section is our deployment of our SQL Server. Hopefully we've typed it incorrectly. We'll find out in a minute whether it's not correct. Here's our cluster IP, which you've seen before, and here's this new concept, well, semi-new concept of a load balancer. So I'm going to pause here for a minute, and then we're going to come back and we're going to apply this deployment and see if we can access our SQL Server. All right, the moment of truth. Now make sure you save your file, and we'll bring up our command line again. We'll clear the screen, and I'll maybe move this up a little bit. Do a directory listing to make sure that you can see your MS SQL plat deployment. And again, you should be getting used to this now. kubectl, apply, F, and I'm just going to copy this in. And this is the moment of truth. If we made a mistake, we'll get an error here. Now that all looks good. So certainly the YAML that we've created is syntactically correct. So you can see here, again, you should be getting used to this now. A deployment's been created. We've got a cluster IP service created, and we also have a load balancer created. So let's do a quick clear the screen, and we'll do kubectl get services. And we should see our SQL Server load balancer available to us on localhost, and we should be able to access our SQL Server using one of these ports here. And then we have our cluster IP service, again, internal to our cluster, available on port 1433. Fantastic. And then if we do kubectl get pods, we should see that our SQL Server is still creating. Now, it could well be that I don't have the SQL Server images getting pulled down from Docker Hub. So we'll just have to keep an eye on that. And hopefully we don't get any errors and it runs up correctly. Now, I've found from my own experience, if anything is wrong with the persistent volume claim or anything like that, and you can't actually mount to the mount point, that's where I've had errors before, and it's caused me a few headaches. But I'm hoping that this gets created correctly. So maybe if I bring up the Kubernetes user interface, we can have a quick look and see what's going on here. So that's the pod running. I'm just waiting to see whether we have a SQL Server running. Not as yet, not as yet. So that's still container creating. So I think it must be doing some stuff in the background. So we're just going to have to wait for this, unfortunately. Let's have a look at that now. Okay, cool. So we have a SQL Server pod up and running. That's looking pretty good. And I'm looking on my other screen here. I've got my Kubernetes kind of user interface up and running, and I can see here that we have SQL Server up and running. That all looks pretty good to me. All right, so what I want to do, quick test, I want to fire up SQL Server Management Studio, and I want to see if I can connect in. So I'm just going to pull that onto the screen here. I'll just resize it, and I'll just connect. And what I want to select is localhost 1433, and I'm going to put in the SA password that we specified. Make sure I type it in correctly. And that's looking pretty good, actually. So we've connected in localhost port 1433, and yeah, we don't have any databases on there yet, which is, yeah, it's looking pretty good. So what I might do, just to test the persistent volume claim is working, although the fact that it's up and running suggests to me that it's working fine. I'm just going to quickly create a test database. It's just, doesn't matter what it is. And we'll just create that, okay. And I'm going to kill that. And then what I'm going to do is we're going to come back over to Kubernetes here, and I'm going to find our, not our pod, I'm going to find our SQL Server container, this one here. And as I've showed you this before, I'm going to kill it. Just delete it. Let's remove it. So it's gone. Now again, there it goes, this one sort of pinging back. As I've said before with Kubernetes, because we've told it via our deployment that we want one running SQL Server, it's going to basically do anything in its power to make sure that that is happening. Looks like we've killed that a few times, don't think I can kill it anymore. And so what I'm wanting to see is the fact that when that SQL Server bounces back up, that it will be using the same persistent volume claim. Log in, Great. And we open this up, and there we go. Our test database is still there. So you saw our container being destroyed and rebooted and all that kind of stuff, and we still have the database that we created. So we can delete this now. We don't actually need that. It was just as a test. Fantastic. So that's good. We've got our SQL Server up and running. We can connect into it externally using this load balancer concept. It should be networked internally. So now what we want to do is we want to actually update our platform service to actually use SQL Server. So we'll do that in the next section. All right, so with our SQL Server now up and running and accessible, which is cool, we're going to turn our attention now to our platform's service, and we're going to set it up so that we can connect to that SQL Server in production in Kubernetes. Now, I think as I mentioned before, when I run this service at the command line, .NET Run, I still want to use the in-memory database. So we're going to have to pick between are we in production, are we in development, and then pick which database we are going to use, or database provider we're going to use. Now, some of you might think that's a bit convoluted. There's various reasons why I made that decision. It's up to you. If you actually want to use SQL Server in development as well, you can absolutely do that. And the way we've set this instance of SQL Server up, as you saw, it's accessible locally as well. But I'm choosing not to do that, and I'll leave it over to you if you want to follow that along. But I suggest if you're following along, you go with what I'm doing here. Anyway, with that being said, the first thing we want to do is create a connection string for production. So with that being said, we're going to come over to our app settings.production.json file, and we're going to add in a connection string that will allow us to connect in to our SQL Server running in Kubernetes. So comma at the end of this attribute here, and then we're going to specify another one called connection strings. Okay, and then take a new line, and then we'll specify, you could specify multiple connection strings here. I'm just going to specify the one that we want. I'm just going to call it platforms con. Doesn't really matter, to be honest with you, as long as it makes sense. So platforms con, platforms connection, and then we specify the connection string. Now this is a connection string for SQL Server. If you're using some other database like Postgres, it would be slightly different, similar but different. The other thing I'll say here is be really, really, really careful that you type everything in absolutely correctly, because this is the type of thing that will cause all sorts of issues if you don't get it absolutely precisely correct. So can't stress that enough. Anyway, I'll do a Control B just to give us a bit more room, and I'll start typing out my connection string. So server equals what? That's the first sort of stumbling block. What is the server we're connecting to? Well, if we come back to our K8s project, K8s, there we go. I'm getting confused, too many projects open. So over in our SQL Server deployment file, here's our deployment of our service, but here is our cluster IP. And again, similar that we've done before, we want the name of our cluster IP service. That is basically what we are connecting into. So we'll come back over here and we'll specify that as our server name, comma, and then the port 1433, then a semicolon. So this is basically our server configuration. We're then going to specify the initial catalog, and that's basically the name of our database. So I'm just going to call that platforms DB. Semicolon again, we're going to specify the user ID, and I'm going to make that equal to the SA account. Now, typically you wouldn't use SA in production. In fact, you wouldn't ever use it at all. Again, just for quickness, I'm deciding to use it. And likewise with password, you wouldn't typically put a password in here, but again, just for quickness, I am going to do that. But calling out is not a great idea. So we produced a secret for our SQL Server, and we read that in from the deployment file. You could do something very similar with this, and you could actually inject environment variables into our platform service. But again, it's kind of taking us away from the core of what we're sort of looking at. So I'm just putting it in here, but yeah, just be aware, it's probably not a fantastic idea to do so. And I'm just going to put a semicolon at the end there. I don't think it matters too much, but I'm just going to do that anyway. So that's our production connection string available. Next thing we want to do is come into our startup class and configure it so that it will work with either the in-memory database, or if it's in production, use SQL Server and use this connection string. So we'll do that next. So still within our platform service project, I'm just going to do a control B to bring up our directory listing and come over to our startup class, and control B again to bring it down. Now, as you'll remember, within our configure services method, we already set up a DB context that uses the in-memory database, which we want to retain, but we also want to add one in now for SQL Server, but not use them both at the same time, as that would be rather confusing. So we want to be able to switch between them depending on what environment we're running in. Now, in order to determine what environment we are running in, I need to inject something called a web hosting environment into our startup class up here and get access to the environment that way. So I'm going to do that first. So in our startup class, in our constructor, I'm going to inject in an iWeb host environment. I'm just going to call it env. Now, this is available to us. There's a few things like configuration, like web hosting environment, that are available to be injected into classes at any point in time. We don't have to set them up within configure services, obviously, because that would be a bit of a circular reference. So this is available to be injected, so you don't need to worry about any other setup from that perspective. And then over here, we'll just declare as usual a private field that we will assign our injected instance to. So again, control period to generate the read-only field, and it puts it down here. Now I'm just going to move these two things up above our class constructor. Don't ask me why, I just think that's where they should sit. That's just my own preference, though. You don't, of course, need to do that. Fantastic. So that gives us access to this env object, where we can now use it to determine whether we're running in production or not. So coming down into configure services, I'm going to create an if statement, and I'm going to make use of our env object, and I'm going to make sure it's an underscore env, and I'm going to determine, is it production? And if so, we want to set up our SQL Server. If not, then we will just use our in-memory database as a bit of a catch-all. All right, fantastic. So all we want to do now in here is set up our DB context that uses SQL Server. Now, what I might do in here is just do a console write line, just so when things are starting up, we can see what is being picked up, and this will come in very, very useful if we start to hit any problems. So I'm just going to say using in-mem DB. All right, and then likewise, I might actually copy that up here, and I will say using SQL Server. Using SQL Server DB, cool. And then all we need to do is just set up a DB context. So using our services collection again, we're going to add a DB context. DB context, it's going to be exactly the same DB context, so app DB context, fantastic. And likewise, we're going to use some options. You can see it looks incredibly similar to what we've already done for our in-memory stuff. I'm going to tab that in, and I'm going to say OPT. So instead of use in-memory database, I'm going to use SQL Server. And then I'm going to pass in the connection string. If you don't get use SQL Server, you might have to add a namespace by doing control period and bringing that in if you don't have that already. And then in order to get our connection string, all we have to do in here is make use of our configuration object, configuration, get connection string, and I say this is why you actually wanted to call this thing connection strings and give it that exact name. That allows us to use this get connection string method. And all we need to do is supply the name of the connection string we want to use. So we'll come back over here and we'll copy this in. All right, fantastic. Save that off. So if we're in production, we'll use SQL Server. If we're not, then we'll use the in-memory database. So what I'm going to do, just as a quick test, I'm going to run this now, and it shouldn't make any difference now. I should still be using the in-memory database. Shouldn't get any errors. It all looks good. So again, we're using the in-memory database. We're connecting, seeding data. All looks good. Shouldn't really have made any difference at this point in time, which is looking great. So the only other thing that I want to be able to do is apply migrations when our database starts up if they've not already been run. And I want to do that from within our prep-db class. We're going to have to actually create some migrations, which we will do at our command line. We have to do that anyway. And then the application of those migrations, we can either do at the command line, or we can set up our class to apply those migrations. So I'm going to set up our class to do it, which makes things a little bit more complex, but I think it's probably a slightly better approach. So before we generate any new migrations, what I want to do is I want to come back over to our prep-db class and get it to apply migrations, but only if it's running in production. If you try and apply migrations when something is running in development, and therefore using the in-memory database, it's not going to like that. So we have to again make this kind of determination when we apply migrations that we're only doing it when we're running in a production environment. So we'll do that next. Okay, let's do a Control-B and go into our data folder and select prep-db, and Control-B again to bring it down. So where I want to actually apply our migrations is when we come to seeding our data. I want to just put it above this section here where we seed data. And I want to be able to determine whether we're in production, in which case we apply migrations, or we don't. So the first thing I want to do is determine if something, and we don't know what that is yet, maybe put a question mark in there. If that's true, then I want to use our context, and I want to access the database, and I want to run migrate, and that will migrate our migrations, which we've not yet created. We still need to actually create and generate our migrations, but assuming we have those, that will run our migrations. So here, I want to basically understand whether we are running in production or not. So how do we do that? Well, the quick way I'm going to do it is by coming back to our startup class. And when we call this method here, additionally, I'm going to pass over, again, we have access to this env object here. I'm going to pass over env is production. So if it's production, we're going to get a true here. I'll save that off. It's erroring out, obviously, because that's not what the method signature currently is. So if we come back over here, up to our method signature, which is prep population, we're going to expect it to take in a boolean of prod. Or maybe we call it is prod. Slightly better. So is prod. If it is, obviously it's true, then we want to percolate that down, if that's the right expression to use, down into our seed data method. So we're going to expect that also to take a bool called isProd, and then finally up here, along with passing over our DB context, we're going to pass over our isProd value, and that should hopefully stop everything from erroring out. And then finally down here, we'll just say isProd. So if it's in production, we'll migrate, otherwise we won't do anything at all. Now in here, I'm going to put a console write line just to let us know that we are applying migrations. So I'll say something like applying, or attempting to apply migrations, ... Okay, and we probably should put this in a try catch block, because potentially this is something that could go not quite right. So we will do that, and we'll say catch exception, and we will then write out console write line. We'll use string interpolation, and we'll say could not run migrations, and we'll give the reason, so curly brackets, ex message. All right, so I think that's us covered. Now again, I'm going to save that off, come back to our startup class. This is still going to get called. It will be running in development, so I just want to run it again and make sure we've not broken anything. So we shouldn't see applying migrations or anything like that. It should all be totally benign. So we come over here, yeah, we just see seeding data using a memory database, so that's looking good. Hopefully, when we do come to deploy it into Kubernetes, that will kick in and it will apply the migrations. Fantastic. However, there is one thing we still need to do, and I actually forgot to do this, and I had to come back and re-record this. I don't know why I forgot it, but I did forget it. And the thing I forgot to do was actually generate the migration. So if you've worked with Entity Framework before, you will understand that you have to do a generate migration, and that actually generates a folder within our, if I do a control B, that generates a folder within our structure called migrations, and it actually has the instructions that we will run against SQL Server in this case. And I didn't do that, forgot completely about that, and ended up in all sorts of trouble. So we need to do that first. We need to do that now. So we're going to do that in the next section. A little bit convoluted, but we'll get that up and running, and then we're then ready to push this all up to Docker Hub and redeploy our platform service, and fingers crossed everything should be working. But let's generate our migrations next. All right, so we want to generate our migrations now. So the way that you will do that is we come back to our project and do control backtick. You'll do .NET EF, don't forget the EF, migrations, add, and then you give your migration a name. So we'll call this initial migration. We'll see what we get. Build start, build succeed. We get some horrible looking error. So without going into too much detail, I was expecting that to happen. And the reason that's happening is because Entity Framework Core thinks we're using an in-memory database, and we are in fact using one, and it just doesn't support migration. So we need to basically trick, if you like, our command line into thinking that we're actually using a SQL Server database or some database provider that supports migration. So there's a few things we need to do here, and it's a little bit kind of convoluted. And this is where you might come to the conclusion that you want to use SQL Server in both cases, in both production and in development, because it actually would make this a lot simpler, and all we need to do is just change our config file, which we're going to do. We're going to have to do that anyway as well. So again, this might be an inflection point where you go, I don't like what I've done here, I want to use SQL Server everywhere. That's entirely up to you. But I'm going to keep going with this because, to be honest with you, it's good practice. It's a good bit of learning to understand what we need to do to kind of fake this a little bit. So all I'm going to do is I'm just going to take out or comment out this if statement. And I'm not going to even determine whether we're running in production or not. And this, again, this is only to get our migrations up and running. We'll uncomment all this again, don't worry. So at the moment, uncomment that out, we're going to be using a SQL Server. All right, and we'll come down here and I'm going to just comment that out. I don't need this to run. I don't want this to run just yet. So I'm going to save that off as well. Now, the only other thing is it still thinks we are running in a development environment. So it's going to come to development settings and see if we've got a connection string. And in fact, we won't. We've only got one in production, and this will not get read in at all. So we're going to have to come over here and we're going to have to copy this. And we're going to have to put it into our development settings as well. The only thing though is this will not work. This is only for use when we are within the Kubernetes cluster. So we're going to have to change that. Any idea as to what? Localhost. So that should be enough. I'm just going to come back to our startup class and just double check. So we've commented this out. We don't want that to run yet, and we don't want to make that determination. We just want to use SQL Server. All right, so control back tick. We'll do up key, and we'll see what we get now. Fantastic. So that all looked good. We're using SQL Server DB because we forced it to. And what you should see over here is this migrations folder has been created for us. And inside of here, you can see that we actually have our migrations being created. And it's basically just a list of instructions telling SQL Server how to create our tables and all that kind of stuff. So that's cool. We've got that now. So what we can do now is we can roll back the changes that we sort of hacked there. I'm going to use that term. And we can have a attempt now at packaging this up, pushing it up to Docker Hub, and then running it in Kubernetes. And we will see what we get. So again, we're going to go back to this setup here, and yeah, it will run in memory, in development, and it will run SQL Server in production. When it does that, we'll come down to prep population, and it will actually attempt to run these migrations that we've now created and migrate our database. And if it's successful, then we will see the creation of a database in SQL Server. So getting quite exciting now. So going to pause here for a minute, and then we're going to build this image, push it back up to Docker Hub, and then redeploy our platform service deployment. And we should see everything come together and working as we're expecting. So we'll do that next. All right, so back over in our project, just at our command line, we are going to build our platform service again. So just do a directory listing to make sure you can see the Docker file and make sure you're in the right space. And then as usual, Docker build t your Docker username, name of the service, and then the build context, which is just where we are at. So a period, so platform service. And again, you know, I can't say it again, can't say it more times. Be really, really careful every step of the way that you spell everything absolutely correctly. One small mistake and things won't work. And I absolutely said it before, guarantee you will make mistakes. So, and if you do get problems, it's more than likely going to be some stupid typo somewhere. I've done it plenty of times, so you will not be alone in that if that happens to you. So we'll just let this build. Cool, that looks like it's built okay, and then we're just going to push it up to Docker Hub. So take out the build context, take out the -t, and we'll just put in push, and we'll push it up to Docker Hub. And then the proof of the pudding is going to be we'll do that rolling restart of our deployment, because as far as Kubernetes is concerned, the actual deployment file for our platform service hasn't changed. We've not changed that. We're just going to do a roll restart so it pulls down the latest image, and we'll see what we get. We'll find out at that point whether we've made a mistake. All right, so that's pushed up. Now what I'm going to do is just come over to Docker Hub and just check that it was updated. Now the reason I like to do this is just in case I maybe misspelled the service name and spelt platform wrong, and we had platform service as well as platform service or something silly like that, which I have done before. And then when you do a rolling restart, you're not actually applying the new image down. And then of course you can come over here and you can have a look and see when it was last updated, and it did say a few seconds ago, and we don't have any weird duplicates or anything like that, which looks all good. All right, so with that being done, I think it's time to move on and actually do a roll restart and see if our migrations are applied to our SQL Server running in Kubernetes. And if we get that working, it's another big massive tick. So we'll do that next. So I will just minimize this, and we can do this from any command line actually. We don't need to do it in our K8s project or anything like that. So let's just clear the screen here. Let's just do a kubectl get deployments. And you can see here we have our 3 deployments, which is looking good. And we want to basically refresh, roll, restart this one here. Okay, so as before, we've done this before. And again, just to labour the point, the reason we're not going into our K8s project and doing a kubectl apply is because from a Kubernetes perspective, it doesn't think the deployment's changed. That deployment file stayed exactly the same. So we have to do this roll restart. So kubectl rollout restart deployment, and then we just copy the name of the deployment we want to restart. And it's been restarted. So clear the screen, kubectl get pods, and you can see here we've got this container creating for platforms, so the new container is being created. And we'll just keep an eye on that, and hopefully we don't get any errors. Give it a couple of minutes to find its feet. And unfortunately, we get an error. So that isn't looking too good. So let's come back over here to Kubernetes and let's find let me see what we got here. Okay, could not run migrations, login failed for user SA. Okay, that's interesting. So maybe I've done something silly and misspelt the password for our SA account. So let's come back over to our settings in production, and let's have a look and see what we have over here. And indeed, I have spelt the password incorrectly, as you will see here, which is really, really annoying. But again, actually, I could have edited this out and pretended it didn't happen, but it's probably going to happen to you. Certainly happened to me. So there should be an exclamation mark on the end of that. Oh my goodness, how frustrating. So we'll save that off. That should be right. Now we could test this locally actually by doing kind of a similar thing to what we did when we generated our migrations and make sure that we can connect in locally. Probably could be a good idea to do that now, but I'm going to be brave, not do that and be a bit foolhardy. So what we'll need to do, and what I'm going to do, is I'm going to kill that deployment because it's a bad deployment. It's not working. So let's do a bit of error management here. So I'm going to do we've already got our, that's our pods. So let's do kubectl get deployments. And we can see we have this deployment and it's just, it's going to be in a bit of distress. So we'll do kubectl delete deployment, and I'm just going to delete this. All right, so that's deleted now. So get our deployments, it's gone. If we get our pods, we have a terminating platforms deployment pod. So that's all good. So that's gone the way of the dodo. So make sure we're still in our platform service. We'll do a directory listing, make sure we have our Docker file. We're going to have to do that whole deployment step again. Now you can automate this, but again, I think when you're learning, I think it's good to go through this pain at least once or twice, and you will be very, very sure not to make these mistakes again. So we'll do a build. So Docker build tag, and then it's binary, in my case anyway, binary thistle / platform service. Okay, I'm just going to double check that, make sure I put the build context in. Get platform service, cool. Let's hit enter. Build that. And that's built, and then we'll just push it up to Docker Hub once again. So let's take out this T and we'll change this to push. All right, we'll push up to Docker Hub again. Now, because we don't have a deployment now, I've destroyed it, we don't have a platforms deployment, we're going to have to go back into our K8s project and we're actually going to have to redeploy, reapply our deployment, okay? Because there's not one there. So you'll see it being created. So again, there's two distinctions there. If we have a deployment and it's running, you do the rollout restart. If we don't have any deployment, we have to do the application of the deployment. So we'll do that. Fingers crossed this time, we'll see what we get. All right, so that's been pushed up. Now again, I'm going to double check Docker Hub to make sure that it has been pushed up. So let's just refresh that. Fantastic, and we'll come in here and we will see it was updated a few seconds ago. And you can also see the count has been incremented. All right, so we do now need to actually go over to our K8s project. So let me just find that. That's this one here, and do a control backtick, and we'll do a directory listing. And we want to redeploy, yeah, we actually basically want to deploy as if we were doing it for the first time, this deployment here. So again, just to labour the point, kubectl get deployments. We don't have a platforms deployment, so kubectl apply F, and we'll copy, should I say, this file here. Paste that in. And what you'll see is that our cluster IP service is unchanged, which is correct. That was already there, and our platform service deployment wasn't there, so it's being created. Great. So kubectl get deployments. Actually, let's do a get pods, because that gives us a bit more detail. So we'll see container creating, and hopefully we don't see that dreaded error. There's nothing worse actually when you see that. It's kind of, your heart sinks a little bit and you think, oh my goodness, what have I done wrong? But it's all part of learning, so it's just part of how things end up being. So we'll check it again, and it's running this time. That is looking good. Let's do it one more time, because I find sometimes it can run. Maybe I spoke too soon, and then It's still running. That's good. So sometimes it can be a bit cheeky. You can do it, get pods, and it's running, and you're all happy. And you just do it again, and it's gone into an error state because it's actually failed. But that looks pretty good. Okay, fantastic. So what we'll do is we'll come over to Kubernetes now. That's not the wrong one. That's the Docker Hub. It looks a bit similar. They're using the same color scheme, so that's why I'm getting a bit confused with it. So let me bring that onto the screen here. And we'll do a quick look at the terminal window to see what we get. So here's our platform service deployment. And we can take a quick look at some of the output that we're getting here. We can see, if I scroll up, yep, we're using SQL Server database. We're attempting to apply migrations, all looking good. And then we're seeding data into our database. So looking pretty good, I think. So the proof of the pudding really is to come back over to SQL Server and refresh it. Refresh this. There we go. We've got a platforms DB. And we should have platforms table. If we do a new query, we should have our seeded data in there as well. So just make sure if you're using this tool that you change it to platforms DB up here. And we'll do a select everything from platforms. Great. Indeed we do. That is looking pretty good. And then if we come over to Insomnia, and I'll bring this up. Make sure you're using the K8 version. We can do get all platforms, and that's all looking good as well. Now what we might want to do if we want to be really, really brave is we want to do a create platform, but this time we'll just duplicate this. And we'll move this into here. And we will just copy this URI into here. And we will create Docker in our database, and that will be the full proof that everything is working. So that's looking good. We get a 201 created. We'll do a get all platforms from here. It's looking pretty good. And then we'll just come back to our SQL Server Management Studio and we'll just execute that. And it's there. Whew. Quite a long section, but a very worthwhile section. So we've got SQL Server up and running in our cluster now. We have using a persistent volume claim, awesome, and then we have changed our platform service to make use of SQL Server and it's running in Kubernetes, but to still use an in-memory database when it's running in development. So a little bit of a nuanced setup. Fantastic. So what we are going to come on to doing next is we're going to revisit our commands service because it's very, very bare bones at the moment. It just basically has that one test endpoint in it. So we're actually going to build that out to be a more fully featured service. You'll probably be quite pleased to hear we're not going to go down the route of provisioning its own SQL Server. We're just going to continue to use an in-memory database for that because we've covered that already. And as maybe as a challenge for yourself or a bit of homework, you can do that. You have all the information now to be able to stand up a SQL Server just for command service. And I'll leave that for you. But yes, in the next section, what we're going to do is revisit our command service and then kind of get it up to speed as a proper service. And then beyond that, we're going to start looking at more interesting messaging between the two services in a proper microservices style. So we'll do that next. Okay, so before we begin coding, let's take a quick look at the endpoints we're going to have to build, stand up in our commands service. Now this conversation is really more a REST conversation as opposed to a microservices conversation. There are some kind of crossover touch points, but for the most part, this really isn't anything really to do with microservices. This is really to do with the fact that our commands service is going to be dealing with two models. A commands model, as you would expect. In fact, let's take a look. A commands model, as you would expect, which will store the command line snippets, but it's also going to have to deal with a platform model. Now, where microservices conversation comes into this, obviously, we are going to spend a lot of time figuring out how to get platforms from our platform service down into our command service and use this concept of eventual consistency where we have something created in one service, our platform service, and it's somehow replicated or transmitted or event-driven, whatever, down to other services, in this case, our command service. So that's the microservice problem. Taking that aside for the moment and just looking at this purely from the lens of the command service, the command service is going to eventually have platform data. Okay, we will solve that problem. So let's say the command service is going to have platforms and it's also going to have commands. Okay, and so what we're really talking about here is how do we enable our command service to work with multi-models. Now, when we talk about just about platforms, a platform you could almost think as the parent resource in this case. And again, our command service is not responsible for creating platforms or anything like that, but what we will allow it to do is allow someone to return the platforms that it is aware of. Okay, so that is what we're going to do next pretty much, and we will put that into our existing platform controller. And you'll remember we did create a platform controller with a test endpoint just to test connectivity. So that's fairly straightforward. But the whole point of this section is really saying that a platform is effectively the parent of a command. And maybe putting it another way, a command cannot exist outside a platform without a platform. So as you can see here with these next three endpoints, they're all going to be part of or reside within the commands controller, which we will set up. And probably the most important thing that you'll note here is that the route for all our actions is going to has to contain the resource ID for a valid platform. So for example, taking a look at how we're going to create a command, we cannot create a command without a platform. Hence, we have to provide a resource ID as part of the route when we are creating a command. And the same rules apply for when we are retrieving commands or even retrieving a specific command. We have to do it in reference to a platform. So again, that's it really for this section. It's really just to get you up to speed on the fact that this is how we're going to have to create our commands controller, and it's going to make reference to valid platforms as part of the route. Yeah, so gets you across that, and hopefully it made sense. If not, then we are going to come on to coding next, for hopefully it will become much clearer. So why don't we get started? All right, so we're coming back into some familiar territory now and back into a more coding type structure, which I personally prefer. And we're going to make sure we're in our commands service project. Now you'll remember, it's been a while, fairly basic. In fact, we didn't really do too much with it at all. All we had was this platforms controller where we had a test post event just to make sure that we could communicate between our services. And that was all we did with it. We don't really have anything else in here. We did, of course, have a Docker file, which we need, and that's not going to change. But other than that, very, very, very basic, even over in our startup class. I don't believe there was too much here. In fact, I didn't even take out the default comments, so I'm just going to do that, which I usually like to do. All right, fantastic. So the first thing we're going to do is create our models. So over in the root of our project, right click, new folder, models. And the first model we're going to create is our platform model. So new file, platform.cs. So we'll create a namespace of command service, and this is models. Fantastic. And we're going to declare a public class called platform. And then we're going to define some properties. So prop, integer, tab across, we'll call this ID. Fantastic. And then prop, we'll call this, we'll give it a type string, and then we'll call it name. And we'll leave it there for the moment. Now what we might actually want to do, and in fact what I might do, is I might put another property in here, an integer, and we'll call it, I don't know, external ID, and that's going to be the primary key of the platform from our platform service, because we might want to keep track of what that is, possibly. So we'll stick a pin in that for the moment, but we'll use that. So this is really a reference to any unique ID that we get given by the platform service. We may want to track that, and of course we have our own unique database ID, which we'll use kind of internally. That's it for now. The other model we want to create is our command model. So right click in models, new file, and we'll call this command.cs. So namespace, command service, oops, models, and again it's a public class called command. And define a couple of properties on it. First one is an integer, we'll call ID, all good. And then the next one, we'll make a prop. This time it's a string. We'll call this one how to. So how to do a particular activity, such as build a .NET project. Next property, we will have that also as a string. Not a string, and we'll call that command line. And then we'll have a few more properties. Still an ID, and this one is our platform ID. So this is the kind of foreign key reference back to our platform parent, if you like. And then finally, we'll create a public platform of type platform. I didn't quite do a property there, did I? But never mind, I'll fill it out manually. Now this is basically what's called a navigation property, so it allows us to kind of navigate between commands and platforms by providing a reference to our platform there. Now, while I remember, let's jump back over to our platform class, and we want to also, in here, make a reference to the fact that we have a collection, or can have a collection, so we'll use iCollection of command objects. So again, this is navigating the other way, and we'll call that commands get and set, and we'll make that equal to a new list of command objects. All right, so we need to bring in a couple of namespaces and correct our spelling. Collection, using system collections generic. I think that should be enough, yeah. So there we go. And the other thing that we do need to do, which I hadn't done, is we'll need to annotate these attributes as well. So I want to make sure that the string, or the name, sorry, is required. We'll make sure the external ID is also required. And we'll make sure that this is required. And we'll also specify that it's a key. And we'll bring in the namespace for data annotations. And that all looks good. So we'll save that off. And then back over in our commands, likewise, we will make this required. We'll also make it the key. Our how to will be required. As with our command line, it wouldn't be a terribly interesting command if we didn't have a command line snippet in there. And then likewise, our platform ID needs to be required. Okay. And we'll bring in the namespace for that. And that should resolve. Fantastic. So I'll save that off. And we'll do a control backtick, and we'll just do a .NET build just to make sure we didn't introduce any strange errors into here. That all looks pretty good. So in the next section, again, with this service, we're just going to use an in-memory database, but we still need to add a database context. And actually within our DB context, we want to set up we'll specify explicitly some relationships between, or a relationship between our platform model and our commands model as well. Entity Framework does a lot of that for us, but if we want to be really explicit about it to make sure we get the exact behavior you want, then you should set up those behaviors, and we do that within our DB context class. So we'll do that next. All right, so we want to create our DB context now. So let's just get rid of this, and back over in our command service, like we did with the platform service, we're just going to right click, new folder, and we're going to call it data. And in here, we're going to create a new file called appdbcontext.cs. And this is, well, the first bit is exactly the same as we have already done for our platform service. So namespace, command service, data, and we're going to declare a public class called appdbcontext. and it's going to inherit from DB context. And we'll bring in that namespace with control period, and then curly brackets. We then want to declare a constructor, so CTOR, tab into this, and we want to declare some DB context options, and of what type, app DB context. And we're going to specify some options. Again, exactly as we've already done for our platform service. All good. And then likewise, we're going to do a couple of properties, DB set, so type DB set, and it's going to be DB set of type platform. Let's bring that space in using command service models, and we'll call that platforms. And then we get a second prop. Again, it's a DB set of type command, and we're going to call that commands. Fantastic. Now, as I said just a little while ago, that should be sufficient, and Entity Framework Core does a pretty good job of wiring up the relationships using its defaults, but just to be on the safe side, I'm going to explicitly declare the relationships between these two entities, because the naming conventions can be a little bit weird when you leave it to Entity Framework Core. So I'm just going to explicitly declare that here. And the way you do that is, yes, within your DB context, but we just need to override a method. So protected, override, what are we overriding? Well, void first of all, and then we're overriding on model creating. And we pass into that a model builder. We'll just call that model builder. And using this model builder, we then specify the relationships we want to declare on our two entities, two models. So entity, first one we're using is platform. And then we just declare the relationships. So we'll say has many. And then we will use a lambda expression. So P goes to P commands. So platform has many commands with one. Again, using a lambda, P goes to P platform. Put the exclamation mark in. And then finally, has foreign key. Lambda expression again. Platform ID. And we'll finish that off with a semicolon. That looks pretty good. And then we kind of do the reverse, going the other way from, for our command. So model builder again, specify the entity we're working with, so type command. Fantastic. And then we just specify it has one. And we use a lambda expression again. P goes to P platform with many. So it's kind of the reverse relationship definition effectively. Commands. And then finally has foreign key. P goes to P platform ID. Fantastic. So we can save that off, and I think that all looks pretty good. So again, we'll just do clear the screen here, and we'll do a .NET build just to make sure that's all humming along nicely. And it is fantastic. So we're going to again use the repository pattern here. So in the next bit, the next section, we're going to add a repository. So we'll do that next. All right, so let's close this down. Let's get rid of our DB context, and still within our data folder, we're going to create our repository interface. So right-click data, new file. We're going to call this I command repo.cs. Namespace as usual. Command service. Oh, not models, data. And then we just declare the interface as public. Interface, we'll call it I command repo. So again, because we'll be using a database, we want to specify save changes, which, you know, we always technically have to do. So save changes. And then I'm going to create a number of method signatures here, and there's some that most of them will make sense, and most of them will service those endpoints that I showed you in the slide where, and there's going to be one that wasn't there because it's not actually an endpoint that we're going to expose via our HTTP controllers, but it's something we're going to have to be able to do when we come on to doing the microservice asynchronous messaging, and that is adding platforms into our database, platforms that we're going to get somehow from our platform service. That's when it really starts to get exciting. So anyway, let's begin. So the first method signature I'm going to declare is a IEnumerable of type platform. A few namespaces to bring here. I'm just going to call it get all platforms. Okay, so that will allow us to get all the platforms from our command service, the ones that it knows about anyway. So let's bring in these namespaces, systems generic, systems collection generic, and our models namespace. Fantastic. Next one is going to be a void, and it's going to be called create platform. So again, we are going to eventually need to create platforms in our database, and we'll do that generally by getting that data from elsewhere, from our platform service. So yep, it will take a platform object ultimately. And then we need to create this method as well, platform exists, and you'll see how that comes into play a little bit later. And into that, we are expecting to pass a platform ID. So basically, this is just checking to see whether this given platform ID does exist within our collection of platforms. And we will use this quite a lot, actually, throughout the rest of the course. And we'll see how that comes into play a bit later. So this stuff is really all about the commands. So I might just actually, you can read the code, I suppose, but I might just put platform. Sorry, this is all about platforms, not commands. This is platform-related stuff, even though it's in our command service. And this next range of methods are really about our commands. And these ones really relate to the endpoints, mostly, that I showed you on the last slide where. So the first one is going to be an IEnumerable. It's going to be a type command. So it's going to return a list of commands. And we're going to call it get commands for platform. And it's going to expect a platform ID. So we give it a platform ID, and we're going to give it back all the commands that relate to that platform ID. The next one is going to be returning back a single command. We're going to call it get command. And into that, we are going to expect a platform ID, but also a command ID. So that's giving us an individual command, if you remember from the routes that we had on the slide. And then last one, possibly the most important, well, as equally important, is void create command. And into that, we're going to expect the platform ID of the platform that we want to create the command on, and then a command object called command. And that's our full range of method signatures that this interface needs to provide for us. And if we just come back just over to this slide here, you'll see here that we have most stuff relating to, so we got something that will give us all our platforms, and then these are our three command-based operations here, getting all commands for a platform, getting a single command for a platform, and then creating a command. And the only one that we didn't have on there is this one here, creating a platform, which we do by other more mysterious, more interesting methods. Fantastic. So that's our interface done. We'll move on now to creating an implementation class for our iCommand repo interface. All right, so we're going to create our concrete implementation class for our command repo interface. So right-click data, make sure I've selected that, right-click data, new file, and we'll call this command repo.cs. So namespace, command service.data, and it's just a public class called command repo. And we're going to implement our iCommand repo interface. Fantastic. And so just click in here, control period, implement our interface. Just before we do actually fully implement it, we've only got placeholder stuff here. I'm going to first create a constructor, so CTOR, and I'm going to pass in an app db context. T in there, and we'll call that context. And we will assign that to a private read-only field called _context. Fantastic, and as usual we need to create that, of course, so control period and generate read-only field. Perfect. So let's move down to the bottom and we'll start working our way up the top. Start with the simplest ones first, so save changes. Again, we need to call save changes anytime we add or delete anything from the DB context, and so it actually gets pushed down to the persistence layer. So context, save changes, and we'll return true if the value of save changes is greater than 0. How many things we have affected or impacted. We'll return true. Next one is whether we have a platform existing in our collection. So we'll pass in a platform ID and return either true or false based on whether something exists. So return context again. And this time we're going to look in our platforms collection and we're going to see if we have anything at all in there matching the following criteria. So control period to bring in the link. And so quick lambda expression, so P goes to P and we will look for the ID and see whether it's equivalent to the platform ID that's passed in. And if so, we'll return true. If it doesn't find anything, then we will return false. Next, we want to get all the commands for a particular platform. So we're going to pass in a platform ID and we will return any commands that we have, if any. We could get a null back. That is a valid response. So return _context, this time in our commands, and we will do where, and we'll do another lambda expression. So C goes to C. This time we're looking at the platform ID to see whether it's equivalent to the platform ID pulled in. And if so, you don't need to do this, but I'm going to do it. We're going to order the results by the platform name, just so we have them kind of grouped together. So C goes to C once again, platform name. Not mandatory, but just makes our result set a little bit nicer. Fantastic. Next one, we're going to get an individual command. So we're going to pass in both the platform ID and the command ID. And so we're going to return context, commands, where, and our where clause is a little bit more complex this time. So C goes to C, and the first thing we'll check is the platform ID to see if it's equivalent to the platform ID passed in. But also, so and, we want to check, see if the command ID is the equivalent to the command ID passed in. Now let's do a control B to get rid of our file explorer. And what we want here is the first or default. Okay, we don't want a full result set, we just want a singular command returned back. Next one, get all platforms. This is pretty easy, so we're just going to return back using the context again. Platforms to list. Simple as that. And then slightly more interesting ones, we've got a couple of create methods here. So the first one is creating a platform. So in order to do that, we first want to check to see if the platform object that was passed in, we're going to make sure it's not null. We don't want to try and add a null value to our collection. So if it is null, then we will throw a new argument null exception. And I'll just bring in the system namespace, assuming I spelt that correctly, and amazingly I did. And we'll say name of plat. Okay, so what model are we throwing an exception on? Assuming it's not null, then we will use our context again, and we'll simply go to our platforms collection and add the platform that we've been given. And then finally, probably the most complex method of all, although it's not really that complicated, we are going to add a command. So we're going to get passed in the platform ID, and we are going to expect a command object passed in as well. Now, we're already getting the platform ID from the URI. So if we come back to our list of methods, let me just find the right slide. I just want to show you what I'm talking about. Here we go. So for create a command, this is going to be our route. So we're going to go platforms, platform ID, commands, and we're going to create a command at that route. So we're already getting the platform ID here. So when we actually pass in the command, although the command does need a platform ID, we don't need to specify that in the body of our create or of our post request. That'll become a bit more clear when we create the DTOs for this. But I'm going to do a little bit of code in here that you might go, why are you doing that? But that's basically why. So basically, similarly to the creating platform, if the command passed in is equivalent to null, then we don't want to do that. So I'm just going to copy this rather than typing it. And instead of plat, it's going to be a command. So assuming it's not null, what we then want to do on the command object that's been passed in, you want to set the platform ID equal to the platform ID that we get in the URI. Now I'll take that out from here. That should be, excuse me, that should be down here. That's why I was getting that warning. So there we go, it's unreachable code. So yes, just to replay that again, we get a command passed in, but we're not going to have a platform ID at that point. We're already getting it in the URI. So I'm going to assign the platform ID to whatever is in our route. And then finally, context. On our commands collection, I'm going to just simply add that command. Fantastic, and I think that's us done. I think that's the concrete class done. That's all our methods implemented. Looks that way anyway. So I'm just going to do a control backtick, and I'm just going to do a .NET build. Make sure we've not broken anything. That all looks good, fantastic. So that's basically our repository done. What we're going to move on to doing next is creating our DTOs, because then next we're going to move on to fully implementing our controllers. But first we need to get our DTOs in place, and then actually we need to do our mappings as well. So we'll do that next. All right, so we are coming on now to creating our DTOs. So Control B to bring back our Command Explorer, and I'm just going to get rid of these for the moment. Well, not get rid of them, but just clear them down. So in our root of our commands service project, right click and new folder, and we're going to create a folder called DTOs. Now we're not going to create all the DTOs that we need right now. We're going to create the ones that map just to the controller actions that we're going to implement. Okay, there are some other DTOs that we're going to create as we move forward, more related to eventing and all that kind of stuff. But these DTOs, we're just creating the ones we need just to service our controllers. So the first DTO we're going to create, I'm not going to go through what DTOs are again because we've already gone through that. The first one I'm going to create is a platform read DTO. So new file, platform read DTO, not .dto, but platform read DTO.cs. All right, and so namespace, command service, DTOs. And it's super simple. It's a public class called platform read DTO. And we're going to have two properties. Prop, first one is the ID. We want to return back the ID of any platforms that we have. And it's an integer, so that's all nice and easy. And then likewise for our name, assuming I can spell prop correctly, but this time it's a string. Not a sting, a string, and it's a type name. So just coming back to our models, just to kind of review, here's a platform model. It's pretty much exactly the same as that. Not quite, but it's got our ID and our name. We're not going to pass back our external ID. We're just passing back our ID and the name. Can of course change that if we so choose to a bit later on, but for the moment, that's all we want. Just quickly looking at our command model, just before we move on any further, we have an ID, a how-to, and a command line, and a platform ID. We actually want to return all of these back via our command read DTO. So back over in DTOs, right click, new file, and we'll call this command read dto.cs. The namespace, command service, DTOs, and it's just a public class called command read DTO. And let me come back to our platform, and I'm just going to copy this in, copy these in here, over here. And I'm going to take out the annotations because again it's a read DTO, so I don't really feel we need those. Take these out, and that's fine. So when we are returning a command object back as part of our response, this is what we're going to be passing back. And we're going to save that off. And the only other one that we're going to implement for what we're doing next in our controller is when we want to create a command. So right click DTOs, new file, and it's command create dto.cs. Namespace, command service, DTOs. Now I appreciate a lot of this stuff is quite boring, we've done it before, but again it's good practice. We've still not really come on to the really interesting stuff yet, which is when we start using eventing and all that kind of stuff. This is just still pretty much web API, to be really honest with you. But we're almost getting there. So again, command service, it's just going to be a public class called command create DTO. Now, again, thinking when we want to create a command, what are the things that we're going to pass over? What do we want to actually create with? And we've come back to our command class. We have an ID, which again, as you know, we do not want to pass over. Like with our platform service, we're not going to supply the ID, so we don't need to include that. I mentioned already, and again, this is maybe still a little bit confusing, we do need the platform ID, but we're not going to expect that as part of our body payload because we already get given it in our URI. So this is surplus to requirements. Although it's still needed, we don't need to get it as part of our body payload. Otherwise, we'd be duplicating the platform ID, and conceivably the route ID and the ID we pass here could be different, it could be confusing. So we're just not going to allow it to get passed over at all. So all really our command create DTO is going to expect is how to and command line platform IDs passed in the URI. So I'm just going to copy this. Hopefully that made sense, but it will when we come on to actually doing it. And again, because it's a read DTO, I'm going to leave these as required, and we'll bring in the data annotations namespace, and I think we're good. Did we, from memory, let's have a look. No, that's good. We didn't put any other considerations on that. So that's all good, so we'll save that off. So I think that's good. So let's just do a quick build again, just to make sure nothing's broken. I don't think that would break anything. Cool, so again, at this point, all we're trying to do is get our commands service up and running almost just from a web API perspective. We'll do a quick test if we can, and then we're going to move on to the more interesting stuff, which is actually getting these services to properly talk to each other using an event bus, and that is going to be coming up in the section that follows. We're almost there, but next we have to do our controller. So let's move on to that. Now actually, just before we move on, I'm actually forgetting a very important thing, and that is AutoMapper. We have not included AutoMapper yet. Again, remember AutoMapper is the glue that allows us to map between our models and our DTOs, and we've not put that in yet. So first thing I want to check is just to check that we included it in our CSproj file, and we did. So over here, AutoMapper extensions, Microsoft dependency injection, we need that in here. And you will also remember it has to go into our startup class, but I don't believe we have done that yet. No, we haven't. So first things first, we want to add AutoMapper into our configure services method. So under controllers, we're going to access our services collection, and we're going to add AutoMapper. And it is there. And again, you'll remember from before, we need to pass in this app domain, current domain, get assemblies, and we'll finish that off. So that allows us to inject AutoMapper in our service. Fantastic. Now this is getting a bit busy now, so I'm going to close all this down. So all it really remains for us to do is actually create the mappings. So again, you'll remember we created a folder for those mappings, or for those profiles, more correctly. So new folder, and we'll call it profiles. Okay, so in the profiles folder, new file, we're going to call our profile commands profile.cs. And its namespace, command service, profiles. Again, be careful with the pluralization of the namespace, profiles, and the automapper class profile that we implement. So public class commands profile, and we're going to implement an automapper class called profile. I'll bring in the automapper namespace, so hopefully you should remember this from last time. And then we just create a constructor called commands profile. We don't accept any parameters, and it's in here that we do our mappings. So just a bit of a refresh, we will specify our source and then our target. Now again, the mappings that we're going to do at the moment are very simple. They just map kind of straight on top of each other, as you will remember from last time. This does get a little bit more complex though. So we will come back in here and update our mappings at some point. But for now, simply create map. And the first one that we want to create is from our platform object to our platform read DTO. So that's when we're giving back platforms from our controller. The source ultimately is a platform model, and the target is a platform read DTO. So I'll just bring in command service models, and I'll bring in the DTO namespace as well. Fantastic. That's our first mapping done. Should make sense. And then the next one, create map, and this is going to be a command, create DTO, and that is ultimately going to be going to a command. Fantastic, and I think that's all we need to do. Oh, and then possibly the third one, create command, or create map, should I say, and the source is going to be a command, and we're going to turn back a command read DTO. So again, likewise, when we're retrieving our command objects, the source is going to be a command, and we're going to be passing back a command read DTO. And that's our three mappings for the moment. And I think this is, yeah, I don't know why that's wrong. There we go, that should be much better. I don't know how that got to be a small p. Anyway, there we go, that's our constructor done. And matching our platform, all good, yep. Maybe it got it from here, that's interesting. I didn't realize that. You can see here that the name of the file is a small p. And that's maybe where it's getting the name of the constructor. I didn't realize that. I thought it would have got it from the class. Interesting. There we go, something I learned. So good pickup there anyway. So we'll save that off. That's our commands profile done. So yeah, now we are truly ready to move on to our controllers. All right, so moving on to controllers now. And if we come back over here, you can see that we had a platforms controller already here that we created just to test this inbound connection. Now you can see it's pretty basic. There's enough here to get us going, but we need to obviously expand upon that. Now we did create a constructor. It's not doing very much at the moment. So as usual, what we want to do is inject in a repository so we can use it and a mapper object. So the first thing we're going to inject in is an I command repo repository, and we'll call that repository. No comma, don't know why I put that in. And we also want to inject an I mapper for automapper, and we'll call that mapper. And we'll bring those namespaces in. So using command service data and using automapper. And as usual, we will assign both of those to private read-only fields. So underscore repository equals repository, and underscore mapper equals mapper. And we'll bring in the namespaces for these. Now, before we move any, so read-only field, and same for this, read-only field. Now, before we move any further with this, this will actually fail if we try and run up this class and or run up the application and attempt to hit one of our action endpoints. We're going to get some horrible errors here, and if anybody can tell why, then you're obviously following along very well indeed. The main reason is that we've not registered our iCommander repo in our startup class, in our configure services method, and actually nor have we configured our database context. We've not registered that either. We weren't using any data services from in here, when we were testing it before, so we set none of that stuff up in our startup class. So if we come over here, you can see our configure services method is looking pretty bare. We just have our controllers, which was there anyway, and then we did add automapper, but we haven't yet registered our DB context, which we need to do, and we haven't yet registered our repository. So before we go any further, we need to do that. So up here, we'll make use of our services collection again, and we're going to add DB context, and it's going to be an app DB context. There we go. We're going to provide some options, OPT. Now I'm just going to get rid of a sidebar for a minute, the directory listing. So lambda expression, if I can type it correctly, OPT goes to use in memory database. And I suspect we need to bring in a namespace for that, so let's do that. Control period to bring in, yep, entity framework core, and then as before we just need to give the in-memory database a name, so I'll just call it anything, it doesn't really matter. And again, we're not going to use a SQL server here, and we're not going to distinguish between environments, we're just using the in-memory database just in the interest of time. But again, I've said it before, key point to note is that this service, the command service, does have its own database. All right, cool, and then finally, that's our DB context registered. We now need to register our repository. So let's put it in here actually. So services, add scoped. So we're going to, when anybody requests an I command repo, we're going to give them, should I spell it correctly? We're going to give them a concrete class, which is command repo. And that's it. So yeah, I think that's all. Yeah, the namespace is there. I think that's right. So let me just do a build, save it first. .NET build. Yeah, that's all good. All right, perfect. So that's all our dependency injection stuff wired up for our data stuff anyway, so we can close that down and we can come back to our controller. So this stuff will now work. So when we ask for one of these, it will get injected in, so that's all good. So we're in our platforms controller at the moment, and let's come back to our slide deck and we'll just have a look at the action that we're going to implement for that. I can find the right slide. Bear with me a second. Here we go. So again, we're going to have two controllers within the command service. We're going to have our platforms controller, and that's just going to allow us to get all our platforms. So let's set on doing that first. So it's going to be a HTTP GET request. No route or anything, it's just going to use the existing route, which as you can see here is API/C and then the name of the controller, which in this case will be platforms. Fantastic. And then it's just a public action result, passing back an IEnumerable of what platform read DTOs. And we'll call that get platforms. It will require a couple of namespaces, so systems collections generic and platform read DTO. So command service DTOs. Fantastic. So I'm just going to do a console write line just to give us a wee bit debugging, because I find that quite useful, especially when things go wrong, as you've seen recently. So I'll just say getting platforms from, oh goodness, command service, or command service more correctly. All right, fantastic. So that should just give us a bit of warning that this controller action has actually been hit when we call it. So we then want to get a collection of, if there are any, a collection of platforms back using a repository. So I'll create a variable called platform items equals, make use of our repository, and let's just get all platforms. I don't need to pass anything into that. So it's inconceivable this could be null, that's okay. And in fact, it is going to be null for very obvious reasons, which we'll cover in a second. And then we're just going to return back an OK and we're going to make use of automapper. So we're going to map from our collection of models to a collection of read DTOs. So mapper, map, what do we want to map to? We want to map to an I enumerable of platform read DTOs. And what's our source? Our source is our platform items. And again, that's just making use of one of our mappings in our profile. So that all looks good. Fantastic. So let's give this a go. Let's run this up, .NET run. And let's come over to Insomnia and test this endpoint. Now it's not going to return anything, it's just going to return an empty set, but I just want to make sure that we've wired everything up correctly and we're not getting any weird issues. So we are running in our local environment. So we're just done a .NET run. So command service, here's the previous test we did on the inbound connection. In fact, we could probably still test that. And that's working okay. If we come back over here, you can see, yep, we've got an inbound post. So again, we'd expect that to continue to work, but at least we've not introduced any new errors. And so the new thing we want to introduce here is basically getting all commands. So new request, not all commands, sorry, get all platforms. Put space in here, there we go, get request, we'll create that. And I'm just going to copy the URI from here, because it's going to be exactly the same. The only difference is it's a get request, not a post request. Send that over. Great, so we get 200 OK and just an empty array of nothing, because there's nothing there. We've not seeded any data, we didn't create a prep, well, we've got a prep D class from memory, haven't we? So we just come over here, Control C that, get rid of this. Bring up our data folder. No, we don't. I forgot. We didn't actually even create a prep DB class like we did with our platform service where we seeded data and all that kind of stuff. We don't even have one yet. We will in a bit, but for now we don't. So there's nothing there. We just have an empty database with nothing in it. So that's cool for the moment. We'll circle back to this problem with the fact that we have no data for platforms, but for the next part, what we're going to do is we're going to finish off the other action results that we need to put into our commands controller. So we'll do that in the next section. All right, so what we want to do now is create our second controller, our commands controller, that will allow us to service requests for commands. So before we do anything, let's just take a quick review of the endpoints we're going to stand up. So we've done this first one, again, and that was in our platforms controller. I should actually pluralize these, but in our platforms controller, we allowed the ability to pull back all platforms. For the remaining three, that's where our new controller comes in, our commands controller. And you'll see in all three instances, the route is exactly the same, with the exception of the second one, which is an additional parameter, the command ID. But taking that aside, all three of these routes are exactly the same. So this is our kind of controller level routes. Let's just take a quick look. API/C platforms, we're then passing in a platform ID in all cases, it's a mandatory requirement, and then our commands resource. And in this case, we're passing through a command ID. So just try and remember that this is the kind of class level route that we need to put in. So back over in our project, right click on controllers, new file, and we're going to call this controller or commands controller.cs. So namespace, as usual, command service, controllers, it's just a public class called commands controller. And we're going to inherit from controller base. I'll need to bring that namespace in. Fantastic. Okay, cool. Now, before we come on to doing constructors or anything like that, we want to actually decorate our class with the fact that it is an API controller. Fantastic. And we also want to specify the route. So if we come back to our platforms controller, you can see the route that the class level, or the controller level route was API/C, and then the name of our controller, which in this case was platforms. Over here, we want to do something similar, but coming again, just to refresh your memory, although it wasn't that long ago, we want to have our route as API/C platforms, Now, bear in mind our controller is our commands controller, so we have to actually write platforms as a string. We need to figure out a way to provide in an attribute, a parameter, platform ID, which we have done before, so it shouldn't be too, in fact, if actually showing you the syntax here, shouldn't be too controversial. And then finally, inheriting the name of our controller. So, back over here, we want to specify the route. And then we just specify the route. So it's API /C /platforms / an instance where we inject in our platform ID parameter, which will be the resource ID of our given platform, and then finally the name of our controller, which we will use the kind of wildcard syntax, so controller. Okay, so that just picks up this commands portion and puts it in here. So that gives us our class level or our controller level route, which is pretty much the same for all our actions apart from one, where we have to add on an additional parameter. Cool, so before we come on to the action results, let's do our constructor. So CTOR, and as usual, I may just get rid of the stuff at the side here, Control B. As usual, we're going to pass in an I command repo called repository, and we're going to pass in an I mapper object as well called mapper, and then private read-only fields. So you should definitely, I did tell you we'd be doing a lot of this stuff, and I know it's probably getting a bit laborious, but again, all good practice. Equals mapper. And we'll bring in the namespaces for each of these. Control period. Not namespaces, my apologies. We're going to generate a read-only field. I'm just so used to saying that, bringing in the namespace. So generate a read-only field for both. And we do actually, we do need to bring in the namespace for these. So let's do that. Command service data and using automapper. Fantastic. So namespaces for these, both these things, and private read-only variables for that. Fantastic. So let's come on to our first action result, which is to get back all the commands for a given platform. So it's going to be a HTTP get. I'm not going to bring up the slide again. I think you've seen that enough. Let me just move this up a little bit. It's going to be a public action result. And what we're going to pass back, we're going to pass back an IEnumerable of what? Of command read DTOs. And we'll call this method get commands for platform. Spell platform correctly. And then we want to pass in the platform ID. Fantastic. So we will get our platform ID from our route up here. So whatever resource or platform ID we pass in, we will get that down here. So bring in the namespaces for IEnumerable, system collections generic, and also for our DTOs. There we go. Now the first thing we want to do, well I want to do anyway, is do a console, bring in the namespace, using system, right line, just to say that we've hit this controller. Again, this is not something you typically do in production, but while we are doing some test code, I think it's useful. So we'll use string interpolation. It will just say hit get commands for platform, and we'll just put the ID in to make sure that's all flowing through correctly. Platform ID. Fantastic. All right, now we don't want to attempt to get commands for a platform if that platform doesn't exist within our database. So the first thing we're going to do, and I'll do a Control B, and we come back to our repository, is we did put this method in here, platform exists, with passing that platform ID, and that's really exists to just check to see, do we have a relevant platform in our collection? If not, then there's no point in trying to do anything else, and we return back a false or not found or whatever. So we'll make use of that now. So we'll say if, and we make use of our repository. If repository platform exists, we'll pass in the platform ID. And actually I want to make this a not. So if it doesn't exist, so exclamation mark. So if we get a false back from this, i.e. it doesn't exist, then we will return a not found HTTP 401. And that's it. We won't do anything else there. Assuming that our platform is valid and it does exist, we want to pull back a variable of our commands. So var commands, and this is coming from our repository, and we want to get commands for platform, and that expects a platform ID, so we just pass that through. And we can be fairly sure that we have at least got a valid platform, having done this check up here. And then we just return an OK, 200 response, and we have to map back, so mapper, map, what we're mapping to, and I enumerable of what, and read DTOs, and what's our source, our commands. Fantastic. Okay, so that looks good. Now, of course, we can try and test this, but we're just going to get a not found. So let's try it. And again, we're going to get a not found because we have no platforms. But again, that's the problem that you're hopefully starting to see. We have no platforms in our entire service. How are we going to get around that? Well, that's really where we come on to using some nice asynchronous messaging to get some platforms into our controller, into our command service. But nonetheless, we can still test this endpoint to some extent to make sure we get a 404 or 401 is it? Can't remember. 404 not found. 401 is not authorized. That's right. So bring up our command line. We'll make sure everything's saved. We'll do a .NET run. And again, it's always useful to run this stuff intermittently just to make sure that we're not introducing anything weird. So I'm going to just duplicate this one. And I'm going to say get all commands for platform. Okay. And in here, we're going to maintain this is the same API C /C/ platforms. We'll put in some arbitrary resource ID for our non-existent platform, and then we'll have to amend this on commands. Okay. So yes, we get a 404 not found, which is what we expect as we don't have any platform IDs, but that looks okay. It looks like that's kind of being hit. And if we actually come back over here, you can see here, we had our, again, exactly the reason why I provide this kind of stuff or put stuff in. We did hit our controller correctly with a platform ID of 1, and we just didn't find anything. So that's all looking pretty good. So I'll take a quick pause here for the moment, and then we'll come on and we'll finish off our other 2 action results for this commands controller. And then we'll start to look at what we're going to do about this problem about not having any commands in this service. How are we going to get them in there? So we'll do that next. All right, so let's just kill that. And yeah, we're going to come on and finish off the final 2 action results or endpoints for our commands controller. So the next one we want to write up is basically to pull back an individual command for a given platform. So it's a HTTP GET. I'm not going to bring up the routes again because I'm sure you've seen them enough already, but you'll remember from this one, we need to additionally pass in a command ID as well. So the controller level route takes us so far, but we need to pass in another parameter, which is our command ID. So HTTP GET, open parenthesis, double quotes, and then we just need to specify in our curly brackets command ID as an additional route parameter. That's all right. And then we also, or I'm going to, specify the name of this action result because we'll make reference to this a bit later when we come on to create a command. And this should start to be familiar from when we created platforms in the last service that we built. So I'm going to call it get command for platform. And that's all good. And then it's just a public action result of type command read DTO. We'll just bring back a single command if we find one. And the name, I'm just going to copy this to make sure it's exactly correct and exactly the same. Don't want to introduce any weird errors into this at this stage. And then I'm going to expect 2 parameters. So the first one is the platform ID. And the second one is an integer as well, and it's the command ID. I'll select that there. Okay, so platform ID is coming from our controller level route here, and the command ID is coming from our action result level route here. Fantastic. So the first thing we want to do actually is do a not very similar, an exactly identical check here to make sure that the platform ID exists. And I'm going to also copy this right line as well. So again, platform doesn't exist, there's no point in doing anything else. So I'll just change the name of this. So get command for platform. I'll paste that in here. And we'll pass through the platform ID, and we'll also pass through the command ID, just to help us with a bit of debugging if it comes to that, command ID. Fantastic. So again, you're starting to see the problem that we're going to hit here. We have no way of, at this point in, getting platforms into this particular service. So all these action results, all three of them in fact, are going to just return a 404 not found because we have no platforms. So the problem, and start to think about it, is how are we getting platforms? How should we get platforms into this service? Should we just create another controller action and just allow us to add platforms? We could do that, but we're not going to, because the whole point is we want to actually get our platforms from our platform service in some nice, elegant way, some event-driven, asynchronous way. Anyway, so yeah, let's just finish off this action result before we delve into that too much further. So yeah, we are doing a platform check to see if it exists. If it does exist, that's all well and good. And what we want to then do is return the individual command. So var command equals repository, and we're going to call our get command method this time. And into that, we're going to pass our platform ID and also our command ID. Now, again, at this point, we may or may not have a command. It's entirely valid use case that there is no command there. That's okay. So we need to check that first of all. So we'll say if command is null, then we go no further and we will just return a not found as before. And make sure we put in the double equal signs for equivalency. We're not assigning it. That's cool. And then, assuming that's okay, then we just return okay. We do, of course, have to use mapper. So what are we mapping? Mapper map. What are we mapping to? We're mapping to whatever we are returning, which is a command read DTO. And what's our source? Just the command object that we have up here, which is non-null. Fantastic. So again, that's all looking good. We'll save that off. We'll quickly run it up. Now again, we're just going to hit this first not found condition here, but we can at least see that we get that number one and it's working correctly, and that we're getting both our IDs coming through correctly. So .NET run. And then back over in Insomnia, we will come into our command service under our local dev, and I'm going to duplicate this. I'm going to call it get command for platform. Okay, and it's going to look exactly the same, except we're going to hit on or put on an additional parameter for our command. Still get a 404, which is fine, but what I do want to check to see in our output is that we are hit the controller and we pass through number one for the platform ID and number 3 for the command ID. So that's about as far as we can take this at this point in time. Cool. So that just leaves the final action result, which is our create command action result. So we'll do that next. All right, so just stop any running services if you have any, and we're back in our command controller, and we're going to write up our third action result. So back down here, pick a new line, and I'm just going to pull this up. So this is a HTTP post this time, and we don't need to specify any additional routes because our controller level route is exactly the one that we want. And again, to labour the point, we have a HTTP get here. It's a different verb, obviously, from HTTP post, so they're hitting the same route, different verbs. It's still unique within the controller, so that's all good. So let's come on to the method signature. So public action result. What are we going to return back? We're going to return back a command read DTO. We're attempting to create a command here. If we do successfully, then we'll pass back the read version of that DTO. So I'll call this create command for platform. And what we're expecting we're expecting again the platform ID and also a command create DTO. I'm just going to call that command DTO. All right, so again, in our route, we're expecting the platform ID, which we are going to get from here. And again, we'll need to perform this same check. And we're also going to expect a command create DTO in our body payload. So again, very similar check. I'm just going to copy this one, in fact. Console write line and our platform check. We'll pop that in here. All I want to do is just change the name of the action result. So hit create command for platform, will pass through the platform ID, perform the check to see if the platform exists. If it doesn't exist, then we return a 404 not found. If it does exist, then we keep going on. So next thing we want to do is create a variable that's going to, not a car, a variable that holds our command model. So var command equals, and we're going to use mapper to map to what type? To a platform, not a platform, a command. We'll need to bring in that namespace using command service model. So yeah, we want to create a command object that's going to hold a command model. And what is the source? The source is going to be our command create DTO here. I'll paste that in here, like so. Fantastic. Now, just a little shout out here, do a control B. You'll remember our command create DTO. We did specify some required parameters. Fantastic. So one of the nice things about using this API controller declaration is that when we hit this action result and we pass in a command create DTO, there's a bit of a validation check using those annotations to make sure that we have those two attributes. You can probably pass in other stuff as well, but this action result will go back with an error if we don't do that. So that's why, number one, it's very nice to annotate create type DTOs, and it's also nice to put in that API controller stuff at the top because you get all that out of the box. Very nice. So we can the point I'm making is we can kind of be sure at this point when we're doing this mapping that we've got a valid object. You could additionally, if you wanted, put this in a try catch block if you wanted to be super careful, but I think we'll be okay for now. Want to keep the code a bit light. So we've got our valid command. We now want to make use of a repository and call create command on it, and we pass forward the platform ID and then the command object itself. And then we always have to call save changes, otherwise that will not be pushed down to our persistence layer, in this case our in-memory database. And then the last thing we need to do, as I've said here, we want to pass back a command read DTO in the body payload, but we also want to pass back the URI, the resource URI, to this resource as well in our headers collection. So that's where this created at route stuff comes in. But before we do that, we want to actually create a read DTO. So var, I'm going to call this command read DTO is equal, I'll use mapper again. You can see how useful AutoMapper is. We're using it all the time. We're going to use it even more going forward. So we want to map to a command read DTO this time. And the source is a model, which is our command that's being created. Now, because we've hit save changes and our model is being created in our database, this command object now has an ID as well. So we have that at this point. So this command read DTO has a valid ID. I'm just going to capitalize the R just to keep things consistent. All right, fantastic. And then finally, we use our created at route command, which again is a little bit convoluted, but nonetheless, you've seen it working before. So created at routes. The first thing we're going to pass in is the name of the endpoint that will host our resource. So in that case, it's name of, and the whole reason we gave this method a name was so we can reference it. So we'll copy this and we'll paste it into our name of method here. Fantastic. And I'm just going to take a new line because this is going to get a little bit busy. And tab in, and then we're going to do new platform ID equals platform ID, command ID equals command read DTO ID, and then finally we'll pass back our command read DTO as well. Okay, so as part of the resource, we need to pass back both IDs for both our platform and our command. All right, I think that should be good, and that returns a 201, obviously. Now again, we can't test this right now. We can test it to some extent to see if we hit this. So let's see if we can do that at least. So save off, and then we'll bring up our command line, and we'll do a .net run. Fantastic, and then we'll bring up Insomnia. Come over here again. And yeah, within our command service in our local dev, we're going to create a new request. So new request, and we're going to call it create command for platform. Great, and that's a post request, and the body will be JSON. So we'll create that off. I'm going to copy the URI from this one here, this request here, because it's going to be exactly the same URI, just a different verb. Fantastic. And then we're going to pass in a command create DTO, so how to, let's say, build a .NET project. And then the other one is command line, and we'll be quite familiar with this now, .NET build. And assuming, you know, platform 1 was the .NET framework. Now I'll just check that the payload I've got here is correct. So back over in our project, let's do a control B, look at our command create DTO, and yeah, we've got two parameters, both required, how to and command line. So that should be okay. Let's send this. We'll get the 404 not found, which is fine, but we'll just come back over here and just check, yeah, that we hit our create command for platform endpoint. Fantastic. So that kind of brings us to the end of this section on building up our commands service. And to be honest with you, it does pretty much most of the things that I want it to do in terms of acting as an API, acting as a service. But the one big missing gap is the fact that there are no platforms in this service. As I said, we could add another action result in here to our platforms controller and allow us to randomly create platforms. That's totally possible, but that would be kind of pointless because our two services are completely then totally independent of each other. And yeah, what's the point in that? So the whole point that we've been building to is that we want to somehow, when someone creates a platform in our platform service, we want to notify our command service that a new platform has been created and add it in to our command service that way. So that is really what we've been building to. We want to use this event-driven messaging architecture to allow us to do that and allow the services to talk to each other in a kind of decoupled way. But nonetheless, there is still a dependency between them. The command service still relies upon the platform service to give it its commands, which is the right thing because the command service is the source of truth. So we're now moving into more exciting territory. So in the next section, we're going to do a quick review of synchronous messaging. We're going to talk a bit about RabbitMQ, and then we're going to stand up RabbitMQ in Kubernetes, and then we're going to add some code into both our services that are going to allow for asynchronous event-driven messaging. So we've been building to this for the last few hours. We're almost there. So in the next section, quick review of messaging, and then onto RabbitMQ. All right, so let's just do a bit of a checkpoint. It's been a while since we've done this overall solution. So we've been looking a lot at the Kubernetes domain. That's cool, and it kind of maps onto this overall solution architecture to some extent, but this is kind of, in my view, the next level up. So let's just do a quick sense check of where we're at. So we've got a platform service up and running to some extent. It's got a SQL Server database, fantastic. We've developed our REST API, and that's pretty much, yeah, that's complete now. The REST-based API is finished. Our internal microservices domain, you could almost map that onto our Kubernetes cluster if you wanted to do that. We have our API gateway, which is our Ingress Nginx controller. We can externally get in and route to these APIs. And again, here's our command service, in-memory database, REST API, which is basically complete. We're not doing any more on that. So this is basically where we're at. And the problem that we were encountering in the last section when we were trying to test our command service was that we have no platforms in there. So what could we do? Well, as we've already kind of done, we in a few sections ago, we created a HTTP client in our platform service that posted or could post data to our command service. So one option would be to create another action result in our command service that would allow us to create platforms using HTTP. That is a totally possible solution. And in fact, what we've already done by posting a test message is basically exactly that mechanism. Just we haven't gone that one step further and added a platform to our internal database in our command service, but we could do that. I'm choosing not to do that because, again, we've talked about synchronous messaging, we've talked about dependency chains and all that kind of stuff, and the platform service needing to know about the command service. So we're not going to do that. Instead, as we've discussed, we're going to introduce a message bus. And this means that any service can drop things onto that message bus, and other services can subscribe to that message bus. And so all the services really need to know about is the message bus. They don't need to know about or be aware of any other services. So when we create a platform in the platform service, it's going to publish a message onto the message bus, and it doesn't care who's listening for those messages. It's just putting the information out there. It might be one service, it might be 100, it might be none. Doesn't matter, doesn't care. And then on the command service side, yes, we are going to subscribe for those events. So in the sections coming up, we're going to look at RabbitMQ, what it is, go into a bit more detail about that. And then we're going to stand up a RabbitMQ message bus in Kubernetes, and that will be the end of the Kubernetes stuff. And then finally, we're going to come back to both our services and implement the publisher and the subscriber functionality. So there's still quite a lot to do. And then just to kind of round off, actually, we'll leave the gRPC stuff for the moment. We'll come back to that when we finish this next section. So that's it for now. Now we're going to move on and do a quick overview of what RabbitMQ is, and then we're going to move over to Kubernetes and stand up RabbitMQ in there. So we'll do that next. All right, so let's go on to talk about RabbitMQ, which is going to be our message broker as part of our solution, or message bus. So what is it? Well, it's a message broker or message bus. It accepts and forwards messages, to put it in its simplest form. Messages are sent by producers or publishers, and messages are received by consumers or subscribers. Messages can be stored in the queue, so it has some degree of persistence. We're not going to be using that in our solution, so if our message bus crashes, then we lose all our messages. But in production type environments, you wouldn't do that. You would allow messages to persist in the event of any failures. But yeah, it's one of the benefits of it. So the idea is messages are published onto the queue. If your services are overwhelmed and can't actually service those requests, the message broker acts as a buffer for those messages. And then as and when you bring more services online, they kind of chew through the messages on the queue. Exchanges can be used to add a degree of routing functionality. Now, we're going to be using an exchange, but we're not going to be routing, okay? So I've got a bit on exchanges a bit in the next slide, actually. So just to clarify what we mean by that. Not probably that relevant to this video, but if you're interested, it uses something called AMQP, Advanced Messaging Queuing Protocol, as well as some others now as well. But AMQP is kind of the sort of traditional message queuing protocol. All right, so we'll come on to talking about this concept of an exchange, which again is definitely a RabbitMQ concept. So there are 4 types of exchange that it provides: direct exchange, fan-out exchange, which is the one we're going to be using, a topic exchange, and a header exchange. Now, I'm really going to talk mainly about the first 2. I'll briefly mention the third one, the topic exchange, and I'm not even going to talk about the header exchange. It's way too obscure for my liking, so it's not even worth bothering your time with it. So the direct exchange, so as it says in the bullet points, it delivers messages to queues based on a routing key. So it's ideal for direct or unicast messaging. So you've got your message broker, you have your publisher, so that could be our platform service, you have our consumer, that's our command service, you have this direct exchange, you have the queue. The publisher will publish a message. So I've created a new platform. It will also attach this routing key, which will place it onto the particular queue, and the consumer will then consume off that queue. So we're not going to use this method. This is the one we are going to use. So RabbitMQ is the message broker, our publisher, which is our platform service. There can be many queues, we don't really care. I think there's only going to be one in our example, but you could have a number of queues, just don't care. We've got our fan out exchange. The publisher will publish its message onto the exchange. In this case, I've created a new platform and the exchange will then fan out to every queue that's bound to that exchange. And then any consumer that's reading from a particular queue will get that message, okay? And so that is what we want, okay? And if there's any routing keys attached, doesn't matter, they get ignored. So it's ideal for broadcast type messages, and this is the method that we're going to use. The publisher doesn't care who's listening, it's just throwing it out there. Now again, depending on how you build out your microservices architecture, you might want to use different types of exchange. If you do want to maybe do more direct type messaging, that's entirely up to you. And maybe this fan out exchange isn't maybe the most appropriate use case for something you're building. But for what we're doing, it's the simplest one. It's the one that we want to use. It keeps our pipe simple, stupid, doesn't do anything. It just basically delivers messages. And that's really what we want. And we build the intelligence into our endpoints. And then finally, we come on to this idea of a topic exchange, and it's kind of almost like a cross between the last two exchanges. Basically, the publisher routes messages to one or more queues based on a routing key. So again, you're using this concept of a routing key used for multicast type messaging. And yeah, it's basically, again, it implements different types of publisher subscriber type patterns. All right, so again, I don't want to use routing or anything like that. I want to just use a kind of, broadcast type message. And that's it. So I think all we really need to be aware of is this fan out exchange. That's what we're going to be using. And so next we're going to stand up our RabbitMQ server in Kubernetes. And then after that, we're going to start working back with our services. So let's move on to doing that. All right, so we're going to come on now and deploy our RabbitMQ instance to Kubernetes. Now, maybe before we come on to writing up our deployment file, let's just check in on our architecture, our Kubernetes architecture. And we've come pretty far. We're almost there. In fact, yeah, this is the last thing we need to do. You'll be quite pleased to hear regarding Kubernetes because it's been quite a long road to travel. So yes, we're going to set up a RabbitMQ container with a cluster IP, and not shown on here, we are going to set up a load balancer that will allow us to access the instance externally. Now we're going to use that to look at the actual container itself, but I'm also going to use it to allow our services to connect to it locally from, doing a .NET run. We're going to connect to it that way from our development environment, rather than waiting until we deploy it into Kubernetes, the services that is, and seeing if they connect in and stuff. We're going to do a bit more testing before we do that, unlike what I did with SQL Server. It'll probably save us some time in the long run. Now, the other thing I wanted to say here is we're going to take quite a simple approach to deploying RabbitMQ in Kubernetes. We're going to set up one instance with no persistence. Now, if you go to the RabbitMQ website and you look at how they recommend to deploy RabbitMQ in Kubernetes, they take a very different approach. Now, it's all very well documented, but it's quite a long, detailed process, and it's very much aimed at a production type deployment. And again, for me, it's coming into this realm of, as a developer, I'm probably not going to be wasting too much time. Waste is probably the wrong word, but spending too much time on creating clusters of RabbitMQ message buses and making sure they have persistence. That for me is outside the realm of my personal remit as a developer. Great if you get time to do that stuff, I generally don't. So all I really care about is that, is there a RabbitMQ server there? Yes, there is. And in our case, we will have one. Just be aware, this is not a production quality or production class deployment. But what we're doing, it's totally fine, but just calling that out. So back over in our K8s project, let's get that up. We're going to create a new deployment for our RabbitMQ instance. So right click, new file, RabbitMQ-depl.yaml. Okay, and the API version, let's get started. Version is apps/v1, and double check everything that you are typing in here, because one mistake and it will go critically wrong, do you know what I mean? So kind as deployment, and we'll probably put a lot of stuff in there, so I want to take that out, deployment, that looks right. Specify the metadata, which is effectively the name of our deployment, and I'm going to call it RabbitMQ-depl. And when you do kubectl get deployments, this is the name that appears. All right, so back to top level, we're going to specify our spec and tab in, and we're going to specify our number of replicas. Here we're going to specify 1. Then come on to the selector stuff, and then tab in for match labels and app, and we're going to call this RabbitMQ. That's all. Take that off. New line, bring your cursor underneath the selector, and we're going to specify our template now, and more metadata. Tab labels, and then app. And it's going to be exactly the same as what we specified here. So let's copy that in, like so. New line, and I'm going to specify a container spec, so put the spec underneath the metadata. It's auto-generated containers, yes, which is correct, name, which is correct. So I'm going to call this RabbitMQ as well. So again, these 3 elements here should all be exactly the same. And then specifying the image, and this time it's RabbitMQ:3-management. And now I'm just going to check the way I've spelt management, because it's a word I frequently spell incorrectly. Now this is just the image that Kubernetes is going to pull down from Docker Hub. The management part relates to a management interface, an optional management interface that we can have. So we're going to pull that image down. And we'll use the management interface just to make sure, number one, that we can access it and it's working. And we'll also see messages dropping on to the message bus as well. And then finally, for our specification of our image, we need to specify 2 ports this time. So ports, tab in, and the first one we want to specify, we'll specify the container port. Get this right, it's 15672. That's the management port that we're going to connect in on. And we need to give it a name. As we have 2 ports, we definitely need to give it a name. So I'm going to call it RBMQ-MGMT-port. Come out again, I'm going to specify our second port, and it's a container port again. And this time it's just 5672. So the same as the management port, except it doesn't have the trailing one. And we need to give it a name as well. So I'm going to call RBMQ-MSG for messaging port. And this is the port that our clients, our services should I say, are going to connect in on. This is just for us to access the web interface. So that's why we have 2 ports there. That all looks good, so let's save that off. Now, again, we need to specify a cluster IP for this. So new line, 3 dashes to separate the config. Looking good. So what I'm going to do is I'm going to come over to our SQL Server deployment. I'm going to copy the cluster IP definition. Now, obviously, we need to change it for RabbitMQ, but to save me typing all this again, we're just going to go through it line by line and change the things that we need to change. So API version v1, it's a service. We're going to give it a name, so we do need to change this. So I'm going to change it to RabbitMQ, cluster IP service. Coming down to our spec section, the type is cluster IP, the selector we need to change, so we're going to change it to match this value here. I'll copy that down and put it in here. Fantastic. And then we come on to specifying our ports. All right, so I'm going to rename our first port, and this will be our management port. So I'm going to give it the same name as this here. It doesn't need to be, but I think just for clarity, I'm going to give it the same name as that. Protocol is TCP. The port is not 1433, it's going to be 15672, and the target port is also going to be 15672. All right, fantastic. So again, just make sure you get these numbers correct. Very easy to type numbers in wrong and get them in the wrong way. I've done that many times before. Especially with SQL Server, I've often specified the port as 1443 as opposed to 1433. That's caused me no end of problems in my life. So try and avoid stuff like that. And then we do need to specify the second port. So again, we're going to give it a name, and this is for our messaging. So I'm going to copy that as well. Paste that in here. I'm going to specify the protocol again. Likewise, it's TCP. And then we specify the port. This time it's 5672. And then the target port is also 5672. So again, I'm just going to highlight this and make sure I get highlights in all the relevant sections. That looks pretty good to me. I think that all looks fine. Fantastic. So save that off. And then the final thing we want to do is create our load balancer. So again, I'm going to come back over to our SQL Server instance. I'm going to copy the config, and we'll go through it again line by line. Just saves me typing it in again. Saves you typing it in again. So again, API version v1, it's a service. Metadata will change the name to RabbitMQ. Load balancer, the type is a load balancer. The selector, again, we want to change to RabbitMQ. And then we need to specify our ports in the same way. So you can see here we didn't actually name our port for SQL Server simply because we only had one, but this time we do want to give it a name because we have two ports. So I'm going to specify that first. Name, and I'm just going to give it the same name as this. Management port up here. I'll specify a management port first, copy. Now again, you can see this Kubernetes definition stuff can get really quite long-winded and quite repetitive and all that kind of stuff, but there's not really any getting around it. So this is the last stuff we have to do. So take comfort in that. So 1.5, unless you enjoy this kind of stuff. Some people like this type of stuff. I personally don't. It's so subject to error. Anyway, so a load balancer, we're specifying our ports. That all looks good. So we've got a name, protocol, port, and a target port. And then finally, we just need to specify the actual messaging port. So we'll give it a name, same name as this. Copy. Protocol is TCP. Port is 5672. And the target port is 5672. Fantastic. So again, just highlight this, make sure we get highlights in the relevant areas. I'll highlight this and make sure we get the highlights in all the relevant areas. That looks pretty good to me. All right, so maybe take a quick pause there. We'll save the file, and in the next section, we will run our deployment, see what we get, and then we'll try and connect in and make sure our instance is running. So we'll do that next. All right, now for the moment of truth. So back in our K8s project, let's bring up a command line. Let's just do a quick directory listing so we can see our RabbitMQ deployment file. Let's just do a quick check, because it's been a while. Do a kubectl get deployments. Just to make sure. Don't know what was going through my head there. kubectl get deployments. Okay, everything's running. Let's do a get pods just to make sure everything's okay. Everything's running, everything's looking good. That's all right, fantastic. So clear the screen and the usual kubectl. Apply F, actually I've done it again. Let's do a listing so I can see the file. Yep, okay, so kubectl. Apply -F and then the name of our RabbitMQ deployment file. And this is where we find out if we've done anything wrong. All right, so that looks good. So syntactically, it's all passed. So we've got a new deployment created. We've got two new services created. So let's do kubectl get services. And we should see, that looks horrible on the screen. Let's just pull this over. That's better. Actually, do a control B, that's better. You can see here we have our two RabbitMQ services. So we've got our load balancer, and we also have our cluster IP, which is our internal stuff. Fantastic, that looks good. So let's do kubectl get deployments again. We'll see how our deployment's going. So it's saying 0 of 1 is ready. So let's check our pods. So it's doing a container creating, so we'll just sit back and have to wait for that. So I presume Kubernetes is pulling that image down from Docker Hub. So we'll just have to wait and see what happens there. And I'm hoping and assuming and expecting that it should run and start okay. So it's running okay. That's cool. But again, I have fallen into the mistake of assuming everything's okay, and then you do another get pods and you see it's errored out. But that looks okay from my perspective. So let's just come over to Kubernetes and have a quick look. Pull this over and take a look. And we can see that, where is it? There we go. Hiding down here that we've got a RabbitMQ container. It looks like it's started up quite successfully. Fantastic. So now what we can do is we can, using our load balancer, we can check to see whether we can access the management interface. So let's just bring over web browser using Firefox. Going back to Firefox, actually, I like Firefox. So localhost, and we want to go into our management port. So 15672. Excellent. So we have got our management interface. Now to log in, it's guest and guest. So we just click login, and you can see here you have logged in. It's all looking pretty good. So that's our RabbitMQ service up and running in Kubernetes. What we're now going to come on to do is revisit our platform service and write a publisher service to publish messages onto the message bus. So we'll do that next. All right, so with our RabbitMQ server up and running in Kubernetes, so available to us in our production Kubernetes environment, but also via our load balancer available to us via localhost, we can now move on to updating our platform service. Now, just so we're clear on what we're doing in the next section, or this section, I'll just bring this up again. So we've got all this up and running. We've just stood up our RabbitMQ message bus, and now we're coming on to working with the publisher component of our platform service, asynchronous client to publish messages onto the message bus. So over in our platform service, make sure you have the right project opened up. The first thing we need to do is add the necessary RabbitMQ client packages into our project, because we don't have those yet. So it's .NET, add package, and it's RabbitMQ.client. So we'll add that in, assuming we've typed it in correctly. I don't think I've typed it in. .NET add package, MW. There you go, RabbitMQ client, there you go. Again, that's why it's always good to have this up, because you can actually see it being added in. Sometimes I don't necessarily pay attention to the output down here. It didn't really look too much of an error. So yes, definitely added RabbitMQ client in. Excellent, so that's the first thing we need to do. And then the next thing we need to do is we're going to set up some config. So when our platform service starts up, it's going to connect to our RabbitMQ message bus. Now it needs to know where to connect to. So it's going to be one thing in development and it's going to be another thing in production. So we're going to update both our app settings JSON files here. So let's do development first. Let's put a comma at the end of this. And the first attribute we're going to set up is RabbitMQ host. You can call this anything you like. I'm just going to call it RabbitMQ host. And in our development environment, that is going to be localhost. Exactly the same as what we did here. And then the second bit of config you want to provide is the RabbitMQ port. And the port in this case is 5672. That's the message bus port, so 5672. And we'll save that off. And I'll do an Alt, Shift, and F to format our file. Save that again. Fantastic. So I'm going to copy this now, and I'm going to copy it and put it into our production file as well. Now, of course, this is not what we will be using in production. That will not be correct. So in order to get what we need to use, let's come back to our K8 project, into our RabbitMQ deployment file. And as before, we have our cluster IP service here. It is the name of our cluster IP service, acts as the name of the server effectively. So we'll copy that. And you've seen that before with how we've used SQL Server. So again, making sure you're in the right config file in production, you'll paste that in like so. So that's our config setup, and we'll read that in obviously when the service starts up. And we've got two different settings for both production and development, which is exactly what we want. So next, what we're going to move on to is we're going to create a new DTO for when a platform gets created in our platform service. We then want to create a DTO for publishing onto the message bus. And you'll see why in a minute, why we have a separate DTO for that scenario. So we'll move on to that next. All right, so let's just review the DTOs that we have. We're still in our platform service and come back to our DTOs. We have two. We have a platform read DTO, which is the DTO we expect back from this service. And again, it's got some kind of domain specific fields like cost and so on and so forth. And also our platform create DTO, which is the one that, we expect when somebody's going to create a platform with us. But we're going to create another one and we're going to call it platform publish DTO. And the whole point of this DTO is that is the DTO that we're going to put on to the message bus. When a new platform gets created, as far as our service is concerned, our platform service, we're going to publish that information onto the message bus, but we're going to publish it in a very specific format. We're not going to include the cost, for example, and we're going to include an additional attribute. So it's exactly what DTOs are meant for, specific scenarios in relation to how we're moving data around our application. So all will become clear when we come to maybe starting to use it, but as a foundational piece, it's the next thing that we need to do. So in our DTOs folder, make sure you're in the platform project, right click, new file, and I'm going to call this platform published DTO.cs. And then again, we're going to specify a namespace. Back in our platform service, we're in our DTOs folder, and it's just a public class called platform published DTO. So what do we want to publish? What information do we want to publish? And I'll just make sure I've spelled this correctly. Platform. Okay, that's definitely correct. Platform. Yeah, cool. That would have caused me some issues a bit later on. So yeah, platform publish DTO. What information do we want to publish onto the wire? So the first property is going to be our ID, which is an integer. So this will be the ID as far as the platform service is concerned. We're going to publish the name of the service, and we're also going to publish another string, which I'm going to call the event, the specific type of event. And you'll see how that gets used a bit later on, although I'm sure you can probably guess how that's going to be used. Now, with our DTO being created, we now need to come back into AutoMapper, into our AutoMappers profile, and create another mapping. So the mapping is going to be as follows. Create map. The source this time is going to be a platform read DTO, and we're going to map it to our platform published DTO. And the reason for that is ultimately the trigger for our event is going to be in our controller, in our platform create action. So we create a new action, it gets created. We're going to ultimately create a model in our database. We're also going to pass back the platform read DTO to our consumers, but we're also now going to put a platform publish DTO onto the message bus. So we're going to have already a platform read DTO. We just want to map that onto a platform publish DTO so we can push it out over the wire onto our message bus. So we have that mapping there. All right, fantastic. So I think that's the DTO side of things done. We're now going to move on to actually creating our asynchronous message bus client. So we'll do that in the next section. All right, so back over in our platforms service, let's just close down all this stuff. And we're going to do a little bit of setup. Well, we've done our setup, but we're going to create our interface now. So we're basically going to create a message bus client. But the way I want to build it is, again, we want to use dependency injection. So we're going to have an interface that specifies the methods that our message bus client can perform. And then we're going to build a concrete class to service that interface. So back over in our project, we're going to create a new top level folder. So in the root of the project, new folder, and we're going to call this async data services. So you'll remember we had asynchronous data services with HTTP for our HTTP command, we're now going to create some asynchronous data services for our RabbitMQ message bus. So in here, we're going to create a new file, and I'm going to call it iMessageBusClient.cs. And we'll just make sure we spelled message bus correct. iMessageBusClient, that's cool. All right, so again, this is just our interface. So actually it's going to look very simple. So namespace, and this interface is actually agnostic of RabbitMQ. It doesn't rely on RabbitMQ namespaces or anything like that. So namespace is platform service, and it's now a new namespace, so ASYNC data services. And it's just a public interface called iMessageBusClient. And we're going to define a new method, void. The method is going to be called publish new platform. And it's going to expect as an input a platform published DTO. Fantastic. So all we need to do really is bring in the namespace for our DTOs. So again, that's it. That is our interface. So we're going to expect to use this message bus client, and this method is saying that we're going to publish any new platforms onto our message bus. Fantastic. So save that off. And then next, we're going to come on and we're going to implement a concrete implementation using RabbitMQ. Now, fair warning, there's a lot of stuff in this class. This next bit is going to be quite long, and again, it's possibly prone to some error, so we'll need to take it quite slow, quite detailed, and we'll go through and build up step by step. So yes, we'll move on to our concrete message bus implementation class next. All right, so back over in async data services, right click, new file, and we're going to call this message bus client. Fantastic. So let's start building this monster up. It's actually not that big, but it's probably the biggest kind of class we've got in our application. So namespace, platform service, and we're in async data services. Fantastic, and it's a public class called message bus client, and we want to implement iMessageBusClient to implement our interface. So control period to implement our interface, and of course it's not fully implemented, it's just a placeholder, but that's okay. And I'm going to do a control B just to give us a bit more room. Now before we actually come on to implementing this method, I want to implement a constructor, a class constructor, and it's within the constructor that we're actually going to set up the connection to our message bus. So CTOR, message bus client, and into this I want to pass an iConfiguration object called configuration, because I want to get access to our config elements that we just specified in one of the previous sections. So let's bring in the namespace for this. And again, be really careful. We don't want automapper configuration. We want Microsoft extensions configuration. So make sure you bring in the right namespace. That has caught me out before. Now again, iConfiguration is one of those things that's just available to us all the time throughout our application. So we don't need to specifically register it in our startup class or anything like that. We just have access to that as a matter of course. So we want to then specify a private read-only field to store or to access our configuration. So underscore configuration equals configuration. We won't bring in the namespace, we will generate a read-only field. Again, you've seen this stuff 100 times already now. Now this is complaining, and I'm just going to do a control B